All right. I think we're live. Mic check 1 2 1 2. Mic check 1 2 1 2. If anyone in the chat can hear me, just push 1. All right, got a confirmation. Thank you for that confirmation. Welcome back to the Black Brain Trust. This is episode 544. Information Technology. Please hit the like button as you come in, share the video if possible, hit that notification bell so you get all the updates from the Black Brain Trust and those posted on the community tab. There's a doc in the description beneath the video for you to follow along with. If you want to engage in this discussion, there'll be a link in the chat for you to click on. When you click on the link, make sure you raise your hand so that one of us can acknowledge you and invite and advance you to the panel. Just as an FYI, Zoom put out another update today, 5.0.4. Make sure you update your Zoom client app before joining the panel. All right, let me make a few adjustments and then we'll get started. All right, let's get started, man. Just give me a second. All right. First person on the panel, Super Triz. What it do, Super Triz?
Hey, what's going on, Mike V? This update, while you're in the back chat before you actually add it to the actual broadcast, you can't hear anything. As opposed to before, you could actually hear pending your addition to the broadcast.
Oh yeah, I gotta make sure I go change the security setting on that. I think it mutes you for whatever reason. Yeah, I'll have to look at that. Thanks for the update.
Yeah.
All right. First item on the docket is from Engadget.com. Astronomers spot a strange, first of its kind asteroid near Jupiter. This should be interesting. Let me expand this out. There's still plenty of opportunity for astronomers to discover strange new objects. Researchers using the University of Hawaii's Asteroid Terrestrial Impact Last Alert System, ATLAS, have found a Trojan asteroid, 2019 LD2, that not only follows in odd orbit ahead of Jupiter, but also sports an icy tail. It's in a unique crossover between asteroid and comet. It only appears to have been active for less than a year, too, which is unusual when Jupiter Trojans are often billions of years old and should have lost their ice a long time ago. More data will be needed to determine just what led to this one-of-a-kind finding, but the university's Institute for Astronomy suggested that Jupiter might have recently captured the asteroid from a distant orbit, or that a collision with another space rock might have exposed ice that was previously safe from the sun's heat. Either way, this revelation could offer more insights about the nature of the solar system and its history. Yeah, I need to buy a telescope. I think we should all have a telescope handy in this day and age. I don't know much about this because this is my first time ever hearing about this, but Jupiter and Saturn seem to be both busy little, or I should say little, but both busy planets at this time. Trish, you have anything you want to add to that?
Yeah, well, Jupiter and Saturn being some of the larger planets in the solar system, and because of their size and mass, they have a larger quote unquote gravitational pull. And I use the term pull loosely because of how we now perceive gravity to be. It's not necessarily a pull. But anyways, because of that, you can expect there to be greater amounts of activity around those planets, just because of the gravity of those two planets, Jupiter and Saturn, many magnitudes larger than Earth. Mm-hmm. As a matter of fact, there's many in the scientific community speculate that Jupiter itself was just basically under the mass necessary to be a star itself. The components of Jupiter, there are many congruencies with that of the sun. So it had all of the actual material necessary, but because of its mass, it didn't have enough mass necessary to begin that initial fusion reaction to gain stardom, quote unquote.
Yeah, thanks for that. That's pretty interesting stuff.
But furthermore, also, I just want to say this is kind of a tangent, but it's interesting that we talk about activity around Jupiter and Saturn, and when we look within our own solar system, there's a lot of stuff going on. Obviously, we're limited by technology in our abilities to explore some of these areas. Saturn and Jupiter both have moons that circulate those particular planets. There's thoughts that there's life in one of the, I don't know if it's Saturn's moon, that is Europa. That's a ice moon. There's beliefs to be liquid water underneath the surface, which may contain life. But at any rate, the point is that we've had conversations regarding, in particular, the asteroid belt, and that there are, asteroids there that may contain precious minerals. And it makes me think of a series called The Expanse. Have you heard of that, a series called The Expanse, Mike?
Yeah, we were supposed to do a live stream about that a couple of years ago. We never did it. I was supposed to have a whole series reviewing it.
Okay, well, maybe that's something that we should talk about at some point. So I won't go too in depth with it, but I'll just say that I actually encourage everybody to watch it and kind of just see the dynamics. There's three factions, and again, it's going to be very brief. There's three factions present. You have the terrestrials, which are Earth, and then you have the Martians, which of course are people who are based on Mars, and then you have what they call belters, who are based on the asteroid belt. And so basically, you have these three factions, and they're based in those specific areas. and obviously different areas have different attributes. Obviously, Earth would have the greatest amount of infrastructure, but Mars and the asteroid belt obviously would have access to more resources that have probably been exhausted on Earth. So it's interesting to see that dynamic on that actual series, and it kind of gives us a possible glimpse into the future, not so distant future, once technology allows us for that level of travel and actually staying in hostile environments a lot longer. You'll see disputes over resources outside of the normal realm that we're used to. But I'll leave it at that. Thanks, Mike.
Yeah, no problem, man. This is from SciTech Daily. New spatial plasma fuel engine, more efficient, longer space missions. Expand this out. Researchers at Charles III University of Madrid have patented a new spatial plasma fueled engine capable of satellite and spacecraft propulsion with magnetic field geometry and configuration that would minimize losses on walls and their erosion, thereby resolving issues of efficiency, durability, and operating restrictions of engines that are currently in orbit. Plasma engines of today consume less propellant than chemical combustion rockets, enabling them to carry out lighter space missions, and as such, less costly ones. However, they have complexity and durability problems. In order to operate, they need metallic electrodes in contact with the plasma, which over time erode to the point that the device stops working. This limits its efficiency and flexibility, since modifying the point of operation without affecting the electrodes is very complex, explained Mario Marino, researcher from the UC3M Department of Bioengineering and Space and Aerospace Engineering. Recently, a new family of electrode-less plasma engines has been designed to solve part of these problems. Nevertheless, Nevertheless, as an incipient technology, it brings some other issues with it. These engines have a cylindrical ionization chamber that is open on one side, where the plasma accelerates due to an applied magnetic field. The drawback is that the magnetic field also thrusts part of the plasma against the back of the wall of the ionization chamber, leading to losses in efficiency, Marino pointed out. I don't know if we're going to get flagged for this, but yeah, I don't want to get flagged for this. New engine patented by UC3M solves this problem by modifying its design. Instead of having a central chamber, it has a U-shaped ionization chamber and magnetic field design in concordance with it, which would minimize the losses of plasma on the walls. The two sides of the U expel streams of plasma in a shape we have baptized as dual magnetic nozzle, Marino continued. This engine would resolve the efficiency and durability problems of the space engines that currently exist, and would provide greater flexibility to the mission by deflecting the plasma stream magnetically without the need to use mobile parts. Additionally, it would meet the needs for propulsion in carrying out space missions in different Earth orbits, such as the Moon or Mars, in a less costly, more efficient, durable way. Yeah, this is something that we had talked about probably a year or so ago about plasma-based engines, and we at first looked into this with Q-based satellites. You can buy a Q-based satellite plasma-based engine. I think it's like maybe $60,000. It's very micro. It's a micro little engines, and it only kind of spits out like a cigarette lighter, sort of propulsion. You know, a little bit here, a little bit there. It's all micro based, but the point of the matter here is that this is the way forward in terms of rocket propulsion in space. The old way of doing it was very costly and um, not very efficient for space travel as a whole. This is why the Mars missions are so uh, long in their trajectory in their planning, because you don't have an efficient method to get back and forth. It's not feasible with the technology that we have today. And this is probably the only way to actually do it. It is through that. Now this can probably go another 10 to 15 years before we even see it get off the ground. Mostly because a Mars mission only happens every few years. I think the next mission is probably like next year or something like that. And then after that, it's like 2027 or something like that. And then it goes into like 2035 for the next mission. It's a long process. So it's a long cycle in the process. And I think that's probably what they're planning out right now.
Yeah, I think a lot of the actual planning goes into, trying to really fine tune the payload. A large portion of the payload is just to escape Earth's orbit, and it's in fuel. Mm-hmm. This plasma drive is something that's really used for outer atmosphere travel. It's not something that's really efficient inside Earth's atmosphere, but outside the Earth's atmosphere, because of its low fuel consumption, is something that could be very useful because it can dramatically decrease the necessary payload. But because of that, because of the decreases in payload, it also decreases cost, depending on what you actually want to send into space. With this emerging artificial intelligence technology and automation, you don't really have to send an entire crew. You can send some type of artificial intelligence, some type of android of some sort into space. And that in itself doesn't require some of the life support systems. So what that means is that because of that decreased cost, smaller governments have the ability to get involved in space exploration as well. And again, when I talk about the expanse, Mars is just one aspect, of space exploration. There's a lot to be had from the actual asteroid belt, as in terms of resources. So that may be an object of exploration as well.
Yeah, thanks for that. Next item on the docket is from ZDNet.com. NASA wants to hire you to spend 8 months in simulated moon, Mars space missions. Speaking of the devil. The National Aeronautics and Space Administration has sent out a call for people interested in spending 8 months in a simulated space mission. The space agency says the job requires applicants to agree to spend 8 months in Moscow, Russia, where a small crew will be kept in isolation to mimic the conditions of a potential future Moon and Mars mission. NASA's spaceflight simulation study is geared towards learning about the physiological and psychological effects of isolation and confinement on humans before the launch of the Artemis mission to the moon, slated for 2024. The Artemis program aims to bring astronauts back to the surface on the moon for extensive exploration and research. Knowledge gained from the mission could then be used to prepare for potential Mars missions in the future, as well as experiencing the confinement and isolation felt by astronauts in space. The crew will be kept busy by conducting scientific experiments, using virtual reality applications, and performing robotic tasks. Results from ground-based missions like this help NASA prepare for the real-life challenges of space exploration and provide important scientific data to solve some of these problems and to develop countermeasures, the agency says. NASA is asking for healthy U.S. citizens to apply for the isolation program. Applicants need to be between the ages of 30 and 55 years old and have proficiency in both Russian and English, as well as an educational level up to PhD or alternatively military officer training. However, there is flexibility in these requirements for the right people. The agency has not revealed exactly how much participants can expect to be paid for the 8-month project. Beyond that, there are different levels of compensation depending upon whether or not you are associated with NASA or if you are a NASA employee or contractor. As the novel coronavirus continues to spread worldwide, NASA has made a point of noting the standard quarantine measures taken with crew members. In the same way that astronauts head into the International Space Station must stay in isolation for at least 2 weeks before launch, entrants to this program will also begin their mission with a quarantine period. In related news, this month, a team of scientists at NASA revealed research into how nuclear power could potentially be used to power human colonies in space. This is going to be very interesting. For those of you who don't understand, nuclear power can last for decades. I mean, you're talking about some of the most advanced stuff coming out of Russia can last up to 100 years. So if they're talking about doing this type of research, that means they got some grand ambitions for putting people out there in space for a long time. How long they can last out there, I don't know.
Well, again, those resources that potentially are within the asteroid belt, if you're on Mars, you're even closer. So if you want to extract resources from, say, for instance, an asteroid, and you can have a stopover or layover in Mars and further refine the products. So that way you get only what you really want, further decrease your payload en route back to Earth. Because again, that's where a lot of your actual expense comes from, is payload. So you want to minimize the payload as much as possible and only take what you actually want. And if you can further refine the raw materials, you eliminate a lot of the excess. So that's something to think about as well. As far as the actual mission itself, I mean that's definitely something interesting. That would be something interesting to put on your resume too, for those of you who are, ambitious and looking to perhaps get into research or maybe even be an astronaut of some sort. I mean, that's a once in a lifetime opportunity. It's definitely not for me, but it'd be interesting to have somebody from the quote unquote ADOS community, or even the broader African diaspora as part of that mission.
We got Nagone 11 on the panel. What's going on, Nagone?
Hey, what's going on? What's going on, Triz?
What's going on, Nagone?
What's going on, man? What's going on? What's going on, Mike? What's going on, fellas?
Man, chilling.
Yeah. But yeah, he's right, man. Certainly, there is great opportunity in certainly getting involved with definitely with that level of space and mining space. I think the big factor also is with a lot of these trips come back from Mars to come back here is with some of these big, I would consider them to be space frigates at this stage. At that stage when they would be going to refueling would be a big thing. You would have to make a lot of fuel. I think maybe maybe the moon and maybe even one of Mars's moons, even though they move, they revolve very quickly around the planet, might be an idea to actually help to kind of refuel, and you might even go out into the asteroid belt possibly and mine that. I know we were talking about that some months ago here on the Brain Trust, but Mars could also be not only a good place to mine and work with, but also another jump off point to where you could go into the asteroid belt, as I said, which would have an unbelievable amount of possible resources that might be considered somewhat endless. So, I mean, the possibilities as to what all this will look like, I mean, it's actually endless. So, and that's something we're definitely going to be doing. in the not too distant future. I would definitely say. So yeah, I think we should have a lot of astronauts. We've always had astronauts kind of in the black astronauts actually, Ron McNair and just famously who actually died on the space shuttle, but we've had quite a few others, and we do have black people in the space program even currently. So I would say that's definitely a very promising career for us, and black people, we need to be there. We definitely need to be there. We've been there, and we still need to be there. That's for sure.
Yeah, we got to be on the forefront of that. One in every 3 startups going forward will be a space startup. So
yeah,
this is something that people should be paying attention to. All right, next item on the docket is from Forbes.com. Has NASA found a parallel universe where time flows backwards? The truth behind the headlines. This sounds real ill. Let me
yeah, it sounds ill.
That article, Mike, as a matter of fact, I read that article before. This is really interesting that you actually put this on the docket. Something I was very interested in.
Yeah, the internet has done it again today, and it bounds with stories from tabloids like the New York Post, Express, and the Daily Star, mostly quoting each other. The major on claims that NASA scientists have evidence that could prove the existence of parallel universes. It's all way overblown and misrepresents what the research in question is about. Scientists actually found signals of fundamental particles that may defy our current understanding of physics. It might even just be an issue with how particles interact with ice. To be clear, there is zero evidence of what the Daily Star says is a parallel universe right next to ours, where all the rules of physics seem to be operating in reverse. Here's what Ibrahim Safa of UW-Madison, who was a lead author on the research paper about the experiment in question in Antarctica, thinks about the current spat of news stories that associate his research with evidence for a parallel universe. NASA has discovered that y'all should not be getting your news from the New York Post. The many articles now online appear to be rooted in a 6-week-old story published by the New Scientist, in which the admittedly alarming headline, "We may have spotted a parallel universe going backwards in time," is backed up by a well-written and thought-provoking article about some puzzling results from studies conducted in Antarctica of cosmic rays arriving from outside Earth's atmosphere, along with some far-out what-if musings about the hard-to-explain origins of these particles. Cue the parallel universe chat. It's all related to the 3 scientific papers. The original research paper from the Antarctic Impulsive Transient Antenna, ANITA, a balloon-based experiment that found upward pointing cosmic rays-like events. A research paper published in response that points that in ANITA results could provide evidence for a CPT symmetric universe, where time would run backwards from the Big Bang and where antimatter would dominate. This is where the parallel universe claims come from, since the paper reads, "In the scenario, the universe before the Big Bang and the universe after the Big Bang is reinterpreted as a universe-anti-universe pair that is created from nothing." A research paper published in the Astrophysical Journal from the IceCube Neutrino Observatory that suggests that we need to consider alternative explanations to explain the ANITA data. However, the only real conclusion is that the standard model concerning neutrinos, fundamental particles, doesn't explain the detection of a rare kind of event by ANITA. ANITA's events are definitely interesting, but we're a long ways away from even claiming there's any new physics, let alone an entire universe. What is an ANITA? It's a stratospheric balloon-based experiment in Antarctica that has a radio antenna pointed back to Earth, back at Earth to detect radio waves emitted by very high energy neutrinos if they strike an atom in the ice. A radio telescope, ANITA, is the first NASA observatory for neutrinos of any kind, hence the NASA connection. What did the ANITA find? In 2016, ANITA detected some signals best described as anomalous, evidence of a high energy particle, extremely high energy neutrinos, coming up from the Earth's surface, but no source. That seemed impossible, according to the New Scientist article, which went on to say that explaining this signal requires the existence of topsy-turvy universe created in the same Big Bang as our own and existing in parallel with it. In this mirror world, positive is negative, left is right, time runs backwards. That's the CPT symmetric universe. The press release about the research paper also mentions that other explanations for the anomalous signals, possibly involving exotic physics, need to be considered. Scientists at the Ice Cube Neutrino Observatory then tried to search for the source of those signals of intent neutrinos. You want to say something to go?
Yeah, I'm wondering if these neutrinos, because I'm starting to think about string theory and a few other things here quickly, but just on some basic stuff, if time is starting to run backwards in this universe, would that also mean that universe that they're potentially feeling that they could sense, is that universe actually shrinking? Because if time's running backwards, would that also mean that universe is not accelerating, but it might be shrinking as well? This sounds really crazy. I don't know.
Well, I mean, like this article posits several things. So it speaks of the actual universe prior to the Big Bang. So when we look at the actual Big Bang, there's allegedly some of the theories surrounding the Big Bang state that there was a singularity, a singularity, a massive, not in size, but an actual density and particles it contains, a singularity. So prior to that singularity, because when we start talking about entropy and entropy, so there had to be a sort of disorder prior to the emergence of the singularity, which initiated the Big Bang. So you will be looking at actual disorder, similar to how our universe is expanding. There would be some sort of disarray and an actual amalgamation of particles that wouldn't necessarily represent a singularity. So like if they posit time is actually going backwards, which I don't really believe. I think that's a misinterpretation of a parallel universe. Because we look at space and time. We look at space and time. Well, yeah, we look at space-time continuum. So we're looking at an interrelation between space and time. So if you look at actual time as like on a number line, right? And you look at like zero could represent, say for instance, zero represents the Big Bang or whatever the case may be, right? And so you have you can traverse anywhere along that number line, either left or right, and you increase the numbers or you decrease the numbers. You get from 0 to 1, 2, 3, or negative 1, 2, 3. And so my interpretation of that is that time doesn't necessarily run backwards. It just runs the space-time continuum moves away from the point of origin. Mm-hmm. So if it's almost like if you look in a mirror, right? Is it necessarily time moving backwards, or if it's just your actual appearance is an analog? So you have an analog of time as opposed to time going backwards. If that makes any sense. You look in a mirror, time is not going backwards. This is an analog of time as it's occurring to the actual observer. So my question is that if time is going backward, how would that actually be perceived by a sentient being? I don't think that's possible.
I would have to say if time is running backwards, because time and space are related and they're both dimensional. So you have the time dimension, and you have the space dimension. And if time runs parallel to space and it is moving backwards, then that would have to say that that dimension of how this time and space are running would be running backwards. Now, if it's running in reverse, would that reverse in fact be forward in that universe? But we're perceiving it from a position of it running backwards, or
Exactly.
or is it actually running backwards, where we would see a literally a shrinkage in time and would in time and in space, because that's what we would be looking at. And would this be moving at the same rates of space and time that we see in our present universe? Would the speed of light and these things be the same? Of which don't know. There's no real answer to that. It's just there's a lot more questions that than could be answered. This sounds really bizarre. So I certainly understand Einstein physics and some of the quantum aspects quite well. I understand string theory is pretty well as also, because looking at these neutrinos, what would be theoretically at the base of these negative neutrinos? Would they be negative strings in there as well? I mean, the shit is crazy. So I'm just trying to figure out what these guys are actually trying to say here.
Well, but my question is that, how does the presence of neutrinos indicate the presence of a parallel universe? The article really didn't go into detail about that,
Right.
because as we know, the neutrinos can arise from a lot of different things, especially when we're talking about elementary particle interaction. Like, say, for instance, you have, there's theorized to be the existence of, beyond neutron stars, hadron stars, in which that the gravity is so dense that the actual there isn't a presence of either protons or neutrons, but the actual base hadrons involved that comprise the proton and neutron, and that the actual electrons move freely in between it. And so because of that density and that interaction, that level of interaction and gravity, those stellar bodies actually emit neutrinos, similar to what we find in the singularities that make up the center of most galaxies. The black holes, the supermassive black holes, actually emit neutrinos as well. So I'm trying to figure out how that presence of neutrinos indicates specifically the presence of a parallel universe.
And you only see neutrinos after really after some collision with another type of particle, which would free those up, and they don't last that long. We talk about the boson and some of these other very exotic particles that exist, the God particle and so forth, which is the baseline creator. I mean, I understand this stuff, but to rock all with this is a little bit strange, because we're talking about a universe that's where everything is supposedly running somewhat in reverse, and it's I'm pretty good at abstract thought, but I'm just trying to see if we're looking at that, is this like a negative universe? Is this kind of like the derivative and the antiderivative, or matter and the antimatter universe? Running. Is this what in fact what we are actually looking at? It's a little crazy, but I definitely would like to hear more. I would like to hear more of this.
Well, again, like when you start talking about that, that space-time continuum, you basically, time is a function of actual movement. So you're moving from a point of origin, and that duration from if you actually plot out separate points, that gives an actual indication or perception of time. So depending on the direction from the point of origin that you're moving, from our perspective as a casual observer, if we were to actually look at a parallel universe, because they're moving at an opposite direction from the point of origin that we are, it would appear that they're moving backwards in time. But in actuality, from their perception, and if you're an inhabitant of that parallel universe as a casual observer, you would appear time to simply be going forward. And people from our universe, if you were to look from that universe at our universe, it would appear as though if we're going backwards. So I think, I guess if that makes any sense.
Yeah. It would almost be the theory of relativity in reverse, depending on, looking at something and how it moves from the relative position that you're at. So, so I would have to look at that, but would everything there have the same constants as you would have here and so forth? So it's just it's if you follow what I'm saying, the constant speed of light and some of these other things, are they the same there as they would be in this universe and all that? Would we be looking at?
You know what? That this brings up an interesting point, because when we say a parallel universe, when we look at parallel, we think of things moving, kind of on the same plane, like maybe one stacked on top of each other side by side. But if we're moving in the opposite direction, is it really parallel? If we have the same point of origin, or is it a different point of origin and we just happen to be moving in a different direction? Is it a perpendicular universe? Like, there's like a lot of questions, like when they start talking about things like that, because there's no specificity as to the direction that time is actually progressing in this said universe.
Well, that's been the question about black holes. What comes out of what happens when it goes out on the other side? It doesn't just go in, something comes out on the other side. So is it a parallel universe on the opposite side of that hole?
Or do you just go down right to the bottom and like what's the man who the brother who heads up the Hayden Planetarium over there? Why am I
forgetting? Talking about Neil deGrasse Tyson?
Yeah. DeGrasse Tyson says, well, you just get extruded into an endless string, and you just ultimately just dissipate.
Spaghettification. It's called spaghettification.
Yeah. So if you dissipate at the end of that, who knows? No one has gone. All the stuff is theoretical. That's all we're looking at is the theoretical game. So I'm just hearing really more about this. I've heard about negative universes and all of this, and we talk about the matter antimatter game, and and what's the smallest particles that we're looking at, besides the quark, and then we're starting to get into the whole theoretical game with strings and everything else like that. So I mean, there's a lot of stuff here. I mean, we can really kind of crank it out, but as of right now, just listening at this, looking at something that's supposed to be moving time in reverse, I would have to look at it more from the physics and that I understand here. In our universe, applying it to that, it would tell me that if things are moving in reverse there, time and space being two key dimensions, we're looking at a universe that's shrinking. that's reverting back, like kind of like when you twist a rubber band, you twist it all the way around, and then you release it, and it goes all the way back. When it goes back to its original position. And I don't know. Are we looking at that?
Yes.
Okay, so if we're talking about if you're talking about a universe reverting back to its origins, at what point?
Don't know. Go ahead. Yes, I'm saying no. Go ahead, Trace. Go ahead.
I was gonna say, like, at what point because at some point in the universe, that parallel universe would have to achieve at some point singularity, because as the celestial bodies get closer and closer together, and that gravity starts to causes those celestial bodies to actually amalgamate, then that gravity will overwhelm that accumulated mass and cause the singularities to form. And so once you get to that point, then what? Like, you get to singularity, and then you have another Big Bang again.
I think that might be a way of how you might open up and start in the creation of maybe another universe. Who knows? You know what I mean? Because you're talking about so much mass now being concentrated in one small single point. You're talking about something that goes, that would be the ultimate of black holes, right? That would be the ultimate at the end. So what what would that be? Would it be able to punch a hole not only through space, time, and into a whole nother fabric of into a whole nother dimension? You're talking about getting into this whole dimensional piece, and that's where we get into the particles and what kind of particles are we looking at, and if string theory is this unified theory, is what type of strings are involved with this that make up this universe. Is it the same that makes up ours, and so forth? Too many questions, bro. Too many questions on this shit. It's like what? Because then you'd have to come up with a whole new level of physics, of which I'm sure we will come up with at some point in time. There's some new theoretical physics that's out here right now that's dealing with some different levels of the universe with respect to not the linear speed nature, physical nature of space and time, but now we're dealing with dimensional movement that deals more with, let's say, a conscious kind of thought, which functions totally differently than what our physical universe looks at. So there's a whole new physics that these guys are trying to evolve, and it's different game. So it's a different, it's a really different game. And I'd like somebody who would be a real expert at this to speak on. Well, there's no experts on this, but there are people who understand this from a higher theoretical standpoint. And I would certainly would like to hear a little bit more about that. But there are some new physics that are in existence.
Well, Mike spoke of potentially black holes being a way to access this other universe, perhaps. But now if there is a way to access this other universe from our present universe, then I would imagine this means that faster than light speed travel is possible. Because think of it from this perspective: if you have a universe that's moving away from the point of origin in the opposite direction that we are, right? If you have light emanating from one point in that universe and light emanating from the same point in our universe but going in opposite directions, it's almost like if I have a car that's going 50 miles an hour, right? And even though I'm going 50 miles an hour, if I hit a wall going 50 miles an hour. But if I hit another car going 50 miles an hour, then actually that collision is a 100-mile-an-hour collision. So
what they're saying is that the expansion of our universe is expanding, and we get into the dark matter area. It expands at a speed that's greater than the speed of light. And yeah, I guess when people look at the four fundamental forces of nature and join them into one, your strong force, your strong nuclear force, your weak nuclear force, your electromagnetic force, and your gravitational force. Those are the four fundamental forces of nature. If those can be merged almost into one, which they think this is what's part of the creative force of the universe, as we see this dark matter as it moves towards the edge of the universe, as we right now are speculating and theoretically looking at, it seems to be moving at a speed greater than what the speed of light would be. So somehow this may be possible without carrying mass potentially. So who knows? I mean, who knows? Right now our physics is limited. It's limited basically to what Einstein basically said, which seems to hold up under all tests, it seems, as well as Newton and others. Apparently, it seems like the ancients understood this as well, with respect to the pyramids. And you could take two pyramids together and take the circumference of both of them and draw a line across and try to figure out what the distances are between them, and you get the speed of light from that as well. So they understood it back then as well, which is unbelievable, but they did. So this speed of light seems to have been a tremendous constant that people understand. They've been understood this for a very long time, but it seems like it doesn't change. But when we're looking at this, looking at kind of this new quantum kind of theoretical game that we're looking at from this, especially from the Big Bang expansion of the universe, it seems that we're expanding at a speed greater than that of the speed of light. So I would have to agree with what you're saying. Is there a greater than light speed? It seems that this is confirm, but we can't seem to mimic this or create this in any type of laboratory at all with the LH collider and so forth. We're not able to do that, though we're able to identify some very exotic particles. But everything seems, speed of light seems to be a constant. So there's got to be something greater out here that can move faster than the speed of light to create, a big bang or expand a universe or so forth. It seems to be there's just some greater forces that we don't seem to fully understand as of yet, and we just don't have a handle on some of this. There's some very theoretical stuff that's out here, but as of right now, in practical science, we don't seem to be able to duplicate anything that's greater than the speed of light. But theoretically, I think you're right about that. But anyway, go ahead, Mike. I'm sorry.
Yeah, let's go to the next article from SciTech Daily. How a quantum physicist invented new code to achieve what many thought was impossible. A scientist at the University of Sydney has achieved what one quantum industry insider has described as something that many researchers thought was impossible. Dr. Benjamin Brown from the School of Physics has developed a type of error-correcting code for quantum computers that will free up more hardware to do useful calculations. It also provides an approach that will allow companies like Google and IBM to design better quantum chips, microchips. He did this by applying already known code that operates in 3 dimensions to a 2-dimensional framework. The trick is to use time as the 3rd dimension. I'm using 2 physical dimensions and adding in time as the 3rd dimension, Dr. Brown said. This opens up possibilities we didn't have before. His research is published today, May 22nd, 2020, in Science Advances. It's a bit like knitting, he said. Each row is like a 1-dimensional line. You knit row after row of wool, and over time, this produces a 2-dimensional panel of material. Reducing errors in quantum computing is one of the biggest challenges facing scientists. Reducing errors in quantum computing is one of the biggest challenges facing scientists before they can build machines large enough to solve useful problems. Because quantum information is so fragile, it produces a lot of errors, said Dr. Brown, a research fellow at the University of Sydney Nano Institute. Completely eradicating these errors is impossible, so the goal is to develop a fault-tolerant architecture where useful processing operations far outweigh error-correcting operations. Your mobile phone or laptop will perform billions of operations over many years before a single error triggers a blank screen or some other malfunction. Current quantum operations are lucky to have fewer than 1 error for every 20 operations. And that means millions of errors an hour, said Dr. Brown, who also holds a position with the ARC Center of Excellence for Engineered Quantum Systems. That's a lot of drop stitches. Most of the building blocks in today's experimental quantum computers, quantum bits or qubits, are taken up by the overhead of error correction. My approach to suppressing errors is to use a code that operates across the surface of the architecture in 2 dimensions. The effect of this is to free up a lot of hardware from error correction and allow it to get on with the useful stuff, Dr. Brown said. Dr. Naomi Nickerson is Director of Quantum Architecture at PSI Quantum in Palo Alto, California, and unconnected to the research. She said this result establishes a new option for performing fault-tolerant gates, which has the potential to greatly reduce overhead and bring practical quantum computing closer. So I'm not going to read all of this. the thing is here is that in basic parallel computing, we have memory in cache that have ECC, which is error code correction. And what happens here is that there is another buffer that is added to the chip itself to handle any sort of errors that does happen before it even processes it. And so in parallel computing, this already happens, but in quantum computing, this was never available. I'm not sure why it took so long for them to really figure this out, especially in quantum computing, because the way quantum computing works, I would have thought that the way it was designed, it was made to have this sort of fault tolerance in every quantum cycle in the qubit. And so I'm not sure what they were thinking when they really designed this out, but it seems to me like it was too complex to actually build into it. And so this is quite an achievement. I'm surprised it took this long for them to figure it out, though.
So it is in fact a complex design.
There you go, man.
Hey, no, honestly, no. Here's the question though, now, Mike, because you're the computer guy. This is definitely not my forte. But okay, so I'm looking at quantum computing. The number of operations that it performs is several orders of magnitudes more than what you consider from what you call a binary computer. Mm-hmm. Is that the difference? That's the terms that we're using, right?
Yeah.
Okay, so is the number of errors a result of the increased number of operations it performs, or is it like just an inherent flaw in the architecture itself?
It's both. It's a combination of both. You're bound to have errors because of the architecture, but then what do you do with the errors is the question. So the problem with quantum computing is that they didn't have a mechanism in place in the architecture to actually do something about it. And plus they're seeing more errors in every few cycles, right? So every 20 cycles, they're seeing one error. And your basic computer doesn't have that issue because it has the ability to have fault tolerance. That's why sometimes if your computer does run into an unexpected error, that error gets isolated, and then you're able to actually restart the program. It's designed to do that. And keep in mind that the chips that we're using in our computers are the architecture is fairly old. All right, let me jump to next item on the docket. We have DE Raptor on the panel as well.
DEMC squared.
All right, this is from allafrica.com. Rwanda government deploys robots in COVID-19 fight. Let me expand this out. The government has launched the use of robots in the government has launched the use of robots in the fight against COVID-19 in a move aimed at reducing contact between medics and patients. The move is expected to limit the risk of healthcare workers from contracting the virus. Launched on Tuesday, May 19th at the Kenya COVID-19 Treatment Center by the Ministry of Health with support from the United Nations Development Program, the 5 high-tech robots can perform a number of tasks related to COVID-19 management, including mass temperature screening, delivering food and medication to patients, capturing data, detecting people who were not wearing masks, among others. Made by Zorobots, a Belgian company specialized in robotic solutions. They are designed with various advanced features to support doctors and nurses at designated treatment centers and can also be leveraged into screening sites in the country. Doctor,
is this some Wakanda stuff, man? This Wakanda, man. I don't hear about this. They don't have clean water, and then women are walking around with dirty feet, man. What are you talking about over there?
We'll see if Shuri from Black Panther will show up. Dr. Ngimi, sorry, I might be pronouncing this wrong, speaks to media after the launch of the use of robots in Kenya COVID-19 treatment center on Tuesday, May 19th. According to the information from the Ministry of ICT and Innovation, the robots have the capacity to screen between 50 to 150 people per minute, capture both video and audio data, and notify officers on duty about detected abnormalities for timely response and case management. Speaking to media, Dr. Daniel, the Ministry of Health said that the idea of using robots is aimed at reducing exposure of health workers to possible COVID-19 infection. Medics and other frontliners visit patients' rooms many times to deliver medication, meals, and carry out tests, among other things. And this may pose a risk of contracting the virus, he said. These robots will fasten service delivery while protecting our valuable health workers against COVID-19 exposure. So each robot costs $3,300. Interesting. And people think that their jobs are not on the line. You're highly finished if you think that a robot costing $3,300 that can do everything you can do times 10. I don't know. You should really do the math on that.
Yeah.
Concerning their use, Dr. Daniel said that the robotics engineers will be trained in the Ministry of Health staff concerning the use of the robots for about 1 month, after which it is expected that the ministry's officials will be able to operate them. An official explains to guests and journalists the various functions of the robots. Paula Gerby, the minister of ICT and Innovation, said that COVID-19 has accelerated the need for digital solutions across various industries, especially in the health sector. There are various innovative solutions being applied to combat COVID-19, and the robots delivered today in these treatment centers will be deployed to support our frontline health workers in treating and containing the pandemic by taking on routine tasks. Well, I was on the continent back in February in Rwanda. There were some robots there, but they didn't do this exactly. But when I was in Qatar back in March, this was there. They had something similar to this. And I had talked about this. If you go back to the archive back in March, I talked about this, that there was some kind of robot that walked around scanning us. And I didn't know what it was because I had never seen it before. And it looked very similar to this. And so the robot had this sort of mechanism that went up and down and scanned your whole entire body. It was really interesting. And I was not able to leave the terminal or go to my next destination until I went past that robot. So I don't know what to tell people. This was a few months ago I saw this. So all this stuff about the continent and, ain't no opportunities over there, and what's in it for African Americans. That's what's in it for African Americans. Okay, that's what's in it for ADOS. These sort of concepts. People from here should be doing this sort of work.
I mean, if you look at these they call them robots, but it's really the dawn of Android technology, because you look at it, there looks to be some type of opposable thumb. You have articulating joints. Mm-hmm. So it's really meant to mimic some of the functions that humans do, as opposed to being one task oriented that we normally associate robotics with. Like a robotics, we kind of associate it with kind of a repetitive task. Mm-hmm. But this looks like, with the right amount of programming, could be doing multiple tasks.
Yeah, it probably already does. It probably already does. Yeah. But it looks like Rosie from the Jetsons. Actually, let me put up a picture for those of you too young to remember Rosie. Go ahead, D Raptor.
Yeah, I mean, this thing looks like it could really be highly interactive as well. Mm-hmm. I mean, Yeah, so yeah, this is robotics. This is 20 years from now. I don't know, man. Things are gonna be a lot different. Is DE there?
I thought he was trying to speak.
Did he have any DE?
I mean, he might be having issues with the the updated app. There was an update that went out today. Yeah, this is Rosie from the Jetsons. That's why I was saying it looks just like her, at least in silhouette. But yeah, there's a lot of opportunity over there for robotics. I can't stress enough. I was over there. I saw it with my own eyes. I saw drones. I was at the African Drone Expo back in February. Bought a late stuff going on over there. I don't know. I was talking with some people from Kenya. They said they used this was back then. They said in 2019 they were using drones to monitor cars and give them tickets and stuff like that. Let that sink into your brain. That's in East Africa. In 2019 they were doing it.
Wait, speaking of jobs, Mike, can you pull up that picture that you just had with all those little those androids were lined up? Can you just pull that up real quick again? Because I really need people to look at this picture now. Now you put some silicone skin over that. OnlyFans and Backpage is gonna be out of business.
Well, Backpage is already out of business, but OnlyFans
OnlyFans is gonna be out of business in a minute.
This is highly butter late, man. This is
highly butter late. This is highly butter late.
Yeah, man. And if you want to get into robotics, man, Udacity actually launched a program for a nano degree in robotics to do this very type of stuff. Let me see if I can pull it up real quick. Let me go on to the next item on the docket. What is this? Oh, here we go. Okay. Share my screen real quick. All right, this is from Udacity, School of Autonomous Systems. You see this little picture right here, the person soldering one of the chips, to powers up the robot itself, the drone. The field of autonomous vehicles is set to grow by 42% within the next 4 years, with salaries for top engineers averaging between $300,000 and $500,000. Advance your career in this rewarding field by studying 15 hours a week. Most people, I've seen some people up in the manosphere spending 8, 9, 10 hours on the live stream. You got enough time to spend on the live stream, you can get this done. Is that somebody trying to talk? All right, so yeah, you got 1 day left to enroll in sensor fusion engineer, self-driving car engineer, intro to self-driving cars, robotics software engineer. That's exactly what you would need to, build a platform like we saw in that Rwanda photo. Flying car and autonomous flight engineer. Let me see, robotics software engineer. Yeah, intro to self-driving cars. Step 2, C++. Step 3, robotic software engineer. Step 4, data structures and algorithms. This is highly, and you're talking about 15 hours a week.
15 hours a week ain't nothing, man.
Yeah. Guys spend 8 hours, 8 to 10 hours on a live stream. Let me drop that in the chat for people.
You got guys spending 8 hours on premium Snapchat.
I didn't even know there was such a thing. Yeah, if you're not going to participate in the chat, just hit the like button, please. right. Let me get to the next item on the docket. All right, this is from TechCrunch.com. African countries need startup acts more than ever to support innovation. Talked about this over the weekend. As the fallout from COVID-19 continues to grip Africa's major economies, the tech ventures in those countries need state support. National legislation that creates clear frameworks and operational support for startups are one of the best ways to to help Africa's digital companies survive and thrive through the coronavirus crisis and improve their environment over the long term. Africa has dozens of thriving startup ecosystems that are persevering through the crisis. But now more than ever, they need a boost. The gains made by founders thus far are in danger due to ongoing economic slowdown. The World Bank estimates that economic growth in sub-Saharan Africa alone will decline from 2.4% last year to 2.1% to negative 5.1% this year. If correct, the region will experience its first recession in a quarter of a century. Now is the time for something that was already long overdue in many African countries. Political leaders should support startups through National Startups Act. Last December, Senegal became the second African nation to enact a National Startup Act following Tunisia's landmark bill that passed in April 2018. Other countries may follow soon. Startup legislation was being discussed in Ghana and Mali before the novel coronavirus monopolized headlines. The rest of the continent can learn a lot from Tunisia, which passed its Startup Act in 2018 after receiving input from entrepreneurs and economists. In addition to clarifying rules surrounding angel, seed, and venture capital funding, the act bestows benefits on companies designated as startups. This includes alleviating their tax and social security contribution burdens, providing access to Forex bank accounts, and offering subsidized salaries for founders. More than 50 startups have taken advantage of the startup label. A number of Tunisian entrepreneurs have told me that thanks to the new legislation, they are able to reinvest their savings. This is the sort of stuff that we talked about over the weekend on the Black Tech Talk. How why I may have not moved to Silicon Valley, or what's going on in Alabama from a startup perspective, the incubators and stuff like that. You need this sort of legislation in the United States to really spawn growth in Black communities. It's the only way you're really going to actually have any sort of prosperity in these communities. These communities don't have to be poor. You can actually allocate funding for these for the Black community if you really want to speak to it to that level. I mean, the Fed pumped $1 trillion into the market a day for the last 30 days, and no one seems to ever bat an eye at that. But as soon as you start talking about legislating some capital from the government to spawn more startups in predominantly Black areas, I mean, people are apprehensive about it, but that's the only way you're going to stabilize the economy in these areas. You have local economies that still matter. Despite the fact that you have a globalized system, a local economy is still relevant in these discussions. There's a lot that can come out of a Black Silicon Valley in each neighborhood. We talked about why the Apple Store is so popular is because it's the cultural experience. People pay for the cultural experience. They can buy it online, but they go into the store for the cultural experience because Apple understands its customers. They understand that people like the environment. They come there for that experience. You can do the same exact thing if you invest into these Black neighborhoods from that perspective. All right, let me get to the next item on the docket. All right, this is from gizchina.com. Huawei releases cable-free, a breakthrough 5G antenna technology. Interesting. Let's expand this out. Huawei recently released a 5G antenna technology called cable-free. This technology comes with major breakthroughs in key areas such as base station antenna integration, radiation efficiency, and power capacity. This device starts a new phase in the development of antennas in the 5G area. According to the company, cable-free technology breaks through the current antenna design bottleneck. It also effectively improves the antenna's capabilities in all aspects. Huawei's new cable-free antenna, like its name, comes with a cable-free design. It also integrates a phase shifter design, which improves antenna integration and antenna performance. Cable-free technology has already been used for a couple of Huawei devices, including Huawei's Munich Pro and Golden Mini and London Pro series antennas, as well as 32T3, 32R massive MIMO products. This helps customers to quickly deploy high-quality 5G networks. Good high band coverage. 5G uses a high frequency band and requires higher antenna for better coverage. At the same time, 5G networks coverage needs to be coordinated by multiple frequency bands. If 1.8 gigahertz, 2.1 gigahertz, and other frequency bands are used as 5G uplinks, high frequency coverage plays an important role in the continuity of a 5G experience. Cable-free technology improves antenna radiation efficiency by approximately 20%. This also increases the antenna coverage quality. In the 5G era, large capacity and high speed requirements need the use of more spectrum and higher order MIMO. The antenna load power increases from 500 or 600 watts to more than 1 kilowatt. Cable-free technology improves the antenna power capacity by more than 80%. With this, it meets the greater output power requirements of the 5G era. Lower weight, easy to install. The high degree of integration of antenna components effectively reduces the antenna weight. Take the 6-band antenna as an example. The overall weight reduces by about 10 kilograms. The weight of the control multi-band antenna is within 50 kilograms. With this, it avoids the use of cranes, thus simplifying the installation process and saving installation costs. So this is actually very positive. If you're looking at this picture right here, they're talking about replacing this sort of technology right here. This is the standard technology that's being used, the cable-based system. And this right here is cableless. This is phenomenal. That means you can mount this anywhere. So now you're talking about you're cutting 90% of the deployment time on a 5G tower. This is phenomenal breakthrough. DE Raptor actually sent this in, so thank you, DE Raptor, for sending this one in. This is something I had not been tracking.
Yeah. When I saw that, Mike, I was like floored, man.
Yeah.
I mean, can you imagine the build-up for one antenna?
Mm-hmm.
They eradicated. I mean, used to take a house and then you got what 4 or 5 miles of cable, and you don't need that anymore.
Mhm.
Plus the antenna itself, you can put the antenna higher because you don't have that additional weight.
Yep.
You got more power because your cables are not going to be putting a drag on your system, sucking power away.
Mhm.
I mean, this thing is going to change it. And the other thing is that Huawei, I don't know how many patents they have on this thing, but it's like you leaving the pushing Huawei a thing between China and the West farther apart, unless the West kind of like uses Huawei technology now, unless they start putting up Huawei towers instead of putting up, keep running with the old cable system towers and spending that money. I don't know if U.S. companies going to let the U.S. government say, hey, you got to spend $1 million more a year to maintain one antenna than going with Huawei and keeping that money in your pocket.
Yeah, well, you could say you can also put this, you can put these pretty much anywhere. So,
yep, you can put them
wow.
further apart. You can put, instead of having 20 antennas in the area, now you can cut that down. I don't know how many you can replace with it. Depends on how many. When I say antennas, I'm talking about the system itself. Because right now they're built to like 20 miles apart. You can expand that and cover more area coverage.
Yeah, the thing is, it does the same exact thing, just cableless, cable free. So, all those traditional, rollouts that they're doing right now that you see Verizon out on the street putting out their 5G towers and stuff like that, all that is obsolete. This makes it obsolete because
Yep.
Huawei has it, and that the United States has an embargo on Huawei. You're talking about this stuff is going to go into Africa and Asia. I mean, we just saw, the United Kingdom kind of, kick Huawei out this week for 5G. But what do you think they're going to see? Huawei doesn't make all of these antenna systems, these communication systems for nothing. They don't just, if the United States says, well, we're not going to be using it in our country. So what? You think that Latin America is not sitting by saying, yeah, please come put these things in there.
Of course.
Yeah, they're saying, yeah, you can come do business here if you want to. Screw the United States. They don't want it. We got
other
it.
European countries as well.
Yeah.
They're definitely African. And with Africa, you can see with all this new technology moving and developing and all that, they're going to be making a quantum leap into the new technology game, and with its deployments as well, because they're beautifully set. They don't have a lot of existing, kind of infrastructure to kind of get in the way. They could just put this stuff right in and up moving. So yeah, it's within their interest to do that. Yeah, I don't know, man. Like I said, we looks like we're kind of fighting against the tide a little bit. So like I said, this is going to go on. These guys are going to get, they're going to be on and cracking. So if we're not up to speed on this, like you said, we're already obsolete here. We may as well get on the bandwagon with this, but it's what it is. It's what it is.
Yeah, let me go to the next article from cleantechnica.com. MIT study says using retired EV batteries for grid scale energy storage could be profitable. Complex Design has been talking about this. There are basically two things that depleted EV batteries can be used for. They can be broken down so their raw materials can be used to make new battery cells, or they can be pressed into service for grid scale energy storage. An EV battery has two critical parameters: energy and power. Energy is what keeps a car rolling at 65 miles an hour on the highway. Power is what allows it to sprint ahead of the guy in the Lamborghini in the next lane when the light turns green. Older batteries may still store plenty of energy, but can't deliver enough power for rapid acceleration. This is true. New research from MIT finds that repurposing EV batteries for grid scale energy storage duties can be profitable for all parties, provided some basic assumptions are met. First, the battery should have a minimum of 80% capacity remaining. Using a hypothetical 2.5 megawatt solar farm located in California as a model, the researchers found adding a new lithium ion storage battery would cost more than reusing repurposed EV batteries, provided the used battery costs 60% or less than their original value. Local regulations can play a crucial role in value calculations. Some local rules allow the price of storage systems to be included in the overall cost of a new renewable energy supply for rate setting purposes, while others do not. A lot of states are really starting to see the benefit that storage can provide, says postdoctoral candidate Ian Matthews. And this just shows that they should have an allowance that somehow incorporates second life batteries in those regulations. That could be favorable for them. There are many issues on a technical level, Matthew adds. How do you screen batteries when you take them out of the car to make sure they are good enough to reuse? How do you pack together batteries from different cars in a way that you know that they'll work well together, and you won't have one battery that's much poorer than the others and will drag the performance of the systems down? The study also examines how to get the maximum benefit from used batteries. I've talked to people who've said the best thing to do is to just work your battery really hard and front load all your revenue. Matthew says, when we looked at that, it just didn't make sense at all. Instead, maximizing the battery lifetime provides the best economic returns. Researchers examined scenarios that kept the batteries in energy storage service until they had only 60% of their original capacity remaining, and found they could be expected to last for 10 years or more in such use. Predicting battery longevity is the subject of much research, Matthew says, because the typical battery has multiple degradation pathways. Trying to figure out what happens when you move into this more rapid degradation phase, it's an active area of research. So you might actually adapt your control algorithms over the lifetime of the project to just really push that out as far as possible. We think that this could be a great application for machine learning methods, trying to figure out the kind of intelligent methods in predictive analytics that adjust those control policies over the life of the project. Matthew says some EV companies are already designing their battery packs specifically to make this end of life repurposing as well as easy as possible. Rivian, found by an MIT alumnus, is one company that is doing so. The economics of second use batteries are sound, Matthew says, but for the idea to get traction, a lot of people in a lot of different fields need to start talking to each other. There's a lot of stakeholders who would need to be involved in this. You need to have your EV manufacturer, your lithium ion battery manufacturer, your solar project developer, the power electronics guys. The intent of the study was to get the conversation started. There will be many more second use batteries available in coming years. Now is the time to start planning how to put them to use in the most efficient and cost effective way. Yeah, this is where blockchain comes in, okay? This is where machine learning comes in. This is where, analytics comes in, big data analytics. Because what's happening here is that, like the article is saying, you have these different various forms of batteries from different sort of products in different sort of markets. None of these batteries, none of this technology, none of these systems even talk to each other. The only way to really record and capture all of this information is to log the charge cycles on each system, especially for cars, because cars go through, depending if they're in New England or in Northwest US or in the South, you go through 4 seasons, especially a long winter, you tend to have degradation for those batteries because of the cold. No one really knows all of this data because there's no way to correlate all this data together. You got to start logging all this information, all the cycles, how many times the battery has been charged, how many times it's been depleted, how many times it's been full capacity, what was the temperature, what was the season, what was the usage of the battery, of the vehicle or the product itself. All that stuff needs to be put onto a blockchain and shared amongst, the resellers or the refurbers who want to actually utilize these batteries for grid scale storage. Maybe in America, that's not the grand scheme of things, but in places like Latin America and that has, dated infrastructure, or in Africa that has dated infrastructure, in Middle East where there's dated infrastructure, there's a lot of opportunity for grid scale storage because you have a lot of desert in a lot of these areas, especially places like the Middle East, places like Egypt, places like Palestine, places like Lebanon and Syria, and places like that, places that have been impacted by various external factors, actually can utilize these sort of renewable energies and energy storage. When I was on the continent, there was a lot of talk about how do we handle load balancing from the grid. Well, you need this sort of grid scale energy storage. That's the only real way to do that. Okay. These are the sort of conversations that I was having over there when I went to the continent, unlike some people.
Hey, if you don't really have to know the battery history in a way, because when when the battery reaches 60%, it's been discharged in a general rule so many times. And when you're moving from a high discharge, high charge, or fast charge environment to a slow depletion, slow charge environment, what you need to do is put the batteries suppose that this battery is now at 60%. You find all the other batteries that are 60%, and the chargers that you put them on, say you put 5 batteries on each charger, and each charger is sensing the capacity of every other battery. You put them in clusters. Say the one that's got 70% left, 60% left, 50% left, and your blockchain is going to control when you change out these batteries, because your blockchain knows when say you want to take them down to, suppose you're using it in a village in Africa or South America or somewhere where people don't have power lines in there. So you're using solar power to charge this, or wind power to charge these. Each one of your banks, you might have 2 or 3 banks in a village, and each one you discharging one each night, and when you discharge it to a level that, I don't know, if it goes down to 10% and it's still possible to recharge it, and you take it down to 10%, and you extend the charging cycle on each bank on every charge. So your battery now is going to last longer than the 10 years that they said it.
Yeah, that's what they're saying it should be designed for. But the problem is you're going to have, if you're using the 80-20 rule where 80% of the battery is good, you want to find out the 20% that's not good. You don't want to add that to your grid scale storage, right? That's what they're trying to prevent. And so they don't know where some of these batteries are coming from because they don't share this information at all, right? If
Right.
Tesla, Nissan, Toyota, they all have their own proprietary batteries, but they could all be repurposed. How do you know which battery is going to be, especially if you talk about 2 out of 3, right? If you Tesla, Nissan, and Toyota, you got to figure out which battery is going to be sustainable and which one is not, because a lot of them do have errors in charging capacity. And so you don't want to bring a bad battery into your network if it's avoidable. And so how do you collect all this information? You got to share the information from the vehicle's computer to know how many times this thing's been charged, and it has to be constantly updated. So there needs to be a way to connect the vehicles to Wi-Fi and aggregate all of that data that's coming from the car, and actually share that data with the necessary resellers and the energy storage companies that are trying to capture those batteries off cycle. And so that's why I said blockchain, because blockchain would actually allow that information to be shared with those necessary parties without actually compromising it. Some of the proprietary information that goes into the design of it. So that was the point that I was making about blockchain.
Yeah, I understand what you're saying. But what I'm looking at it is from what I know about charging systems and batteries, because that's the we had like intelligent charging systems on airplanes. The battery was a dumb battery. It wasn't the type of battery you have in the car, but you still have certain cycles. Like, suppose you have, I don't know, it used to go in time. Instead of cycles, it would go, you had a timer on it. And we know that by the time we change out that battery off the airplane, the the battery actually would have been deep cycled probably about 500 times. You know what I'm saying? When we change out the battery, send it back to the shop to get redone. Mm-hmm. And if it lasted 3 years on that airplane, sometimes that airplane, the battery will stay on that airplane for 5 years. And it's supposed to be taken off 3 years. Somebody forgot about it. Zoom. But the battery is still live battery. They just take it off because they don't want it to fail, because they feel that, this battery can fail any day. And that's the reason to take it off. That's why I was saying that, you can check the battery yourself. And then you don't need, because a lot of this information car dealers are probably not going to give you.
No, they don't have to. They don't have to actually give. Well, if they're going to partake in the program, they would have to share it. That's the thing. They would have to share that information. That's what they're saying.
Right. They're trying to get the dealers to kind of like, instead of throwing away the battery, just continue life of the battery. Well, it would make sense. Yeah.
Yeah. Well, not so much the dealer, but the actual manufacturer. Right, because the manufacturer may want the battery to resell for themselves.
Right.
But in reality, if they sign a partnership with whoever it is, the grid scale energy storage solution company, they may say that battery that has this serial number needs to go to this vendor in California or in Top A or something like that. That's how it's supposed to work, at least according to the article. Let me go to. Let me go to the next article. SciTech Data Daily. Artificial intelligence helps researchers upcycle waste carbon with record efficiency. Researchers at the University of Toronto Engineering and Carnegie Mellon University are using artificial intelligence to accelerate progress in transforming waste carbon into a commercially valuable product with record efficiency. They leverage AI to speed up the search for the key material in a new catalyst that converts carbon dioxide, CO2, into ethylene, a chemical precursor to a wide range of products from plastics to dish detergent. The resulting electrocatalyst is the most efficient in its class. If run using wind or solar power, the system also provides an efficient way to store electricity from these renewable but intermittent sources. Using clean electricity to convert CO2 into ethylene, which has a $60 billion global market, can improve the economics of both carbon capture and clean energy storage, says Professor Ted Sargent, one of the senior authors on a new paper published on May 13, 2020. Sargent and his team have already developed a number of world-leading catalysts to reduce the energy cost of the reaction that converts CO2 into ethylene and other carbon-based molecules. But even better ones may be out there. And with millions of potential material combinations to choose from, testing them all would be unacceptably time consuming. The team showed that machine learning can accelerate the search. Using computer models and theoretical data algorithm can toss out worse options and point out the way toward more promising candidates. Using AI to search for clean energy materials was advanced at a 2017 workshop organized by Sargent in collaboration with the Canadian Institute for Advanced Research, CIFAR. The idea was further elaborated in a Nature commentary article published later that year. Professor Zachary Ulysses of Carnegie Mellon University was one of the invited researchers at the original workshop. His group specializes in computer modeling and computer modeling of nanomaterials. With other chemical reactions, we have large and well-established data sets listing the potential catalyst materials and their properties, says Ulysses. With CO2 to ethylene conversion, we don't have that, so we can't use brute force to model everything. Our group has spent a lot of time thinking about creative ways to find the most interesting materials. The algorithms created by Ulysses and his team use a combination of machine learning models and active learning strategies to broadly predict what kinds of products a given catalyst is likely to produce even without detailed modeling of the material itself. So this kind of points to the article that we were talking about earlier, previously, about how they'll go about finding, these sort of efficient batteries. And this article mentions using artificial intelligence and machine learning to model this stuff out. This is very important because that's like it says, it's not humanly possible to actually do it, or at least feasible at this point to do it. All right, this is from Wired.com. Is the brain a useful model for artificial intelligence? In the summer of 2009, the Israeli neuroscientist Henry Markham strode onto the TED stage in Oxford, England, and made an, it made a modest proposal. Within a decade, he said he and his colleagues would build a complete simulation of the human brain inside a supercomputer. They already spent years mapping the cells in the neocortex, the supposed seat of thought and perception. It's a bit like going and cataloging a piece of the rainforest, Markham explained. How many trees does it have? What shapes are the trees? Now his team would create a virtual rainforest in silicon from which they hope artificial intelligence would organically emerge. If all went well, he quipped, perhaps the simulated brain would give a follow-up TED Talk beamed in by hologram. Markham's idea that we might grasp the nature of the biological intelligence by mimicking its forms was rooted in a long tradition dating back to the work of the Spanish anatomist and Nobel laureate Santiago Ramon in the late 19th century, Cajal undertook a microscopic study of the brain, which he which he compared to a rainforest so dense that the tree trunks, branches, and leaves touch everywhere. By sketching thousands of neurons in exquisite detail, Kajal was able to infer an astonishing amount about how they worked. He saw that they were effectively one-way input output devices. They receive electrochemical messages in tree-like structures called dendrites and pass them along through slender tubes called axons, much like the junctions of electric conductors. Kajal's way of looking at neurons became the lens through which scientists studied brain function. It also inspired major technological advances. In 1943, the psychologist Warren McCulloch and his protege Walter Pitts, a homeless teenage math prodigy, proposed an elegant framework for how brain cells encode complex thoughts. Each neuron, they theorized, performs a basic logical operation combining multiple inputs into a single binary output of true or false. These operations, as simple as letters in the alphabet, could be strung together into words, sentences, paragraphs of cognition. McCulloch and Pitt's model turned out not to describe the brain very well, but it became a very key part of the architecture of the first modern computer. Eventually, it evolved into artificial neural networks, now commonly employed in deep learning. These networks might be called neural-ish. Like McCulloch Pitt's neuron, they are impressionistic portraits of what goes on in the brain. Suppose you're approached by a yellow Labrador. In order to recognize a dog, your brain must funnel raw data from your retinas through layers of specialized neurons in your cerebral cortex, which picks out the dog's visual features and assembles the final scene. A deep neural network learns to break down the word simile. The raw data flows from a large array of neurons through several smaller sets of neurons, each pooling inputs from the previous layer in a way that adds complexity to the overall picture. The first layer finds edges and bright spots, which the next combines into textures, which the next assembles into a snout, and so on, until out pops a Labrador. Despite these similarities, most artificial neural networks are decidedly unbrain-like, in part because they learn using mathematical tricks that would be difficult. This is very true, if not impossible, for biological systems to carry out. Yet brains and AI models do share something fundamental in common. Researchers still don't understand why they work as they do. What computer scientists and neuroscientists are after is a universal theory of intelligence, a set of principles that holds true both in tissue and in silicon. What they have instead is a muddle of details. 11 years and $1.3 billion after Markham proposed his simulated brain, it has contributed to no fundamental insights to the study of intelligence. That's too bad. Actually, this is a very good point. It's possible that AI models don't need to mimic the brain at all. Airplanes fly despite bearing little resemblance to birds. Yet it seems likely that the fastest way to understand intelligence is to learn principles from biology. This doesn't stop at the brain. Evolution's blind design has struck on brilliant solutions across the whole of nature. Our greatest minds are currently hard at work against the dim, almost intelligence of a network. Of a virus. Its genius borrowed from the reproductive machinery of our cells, like the moon borrows light from the sun. This is very interesting. All the more reason why you all should be getting into artificial intelligence. Okay, machine learning and artificial intelligence. I mean, we did a whole entire tech talk on this with engineering cannabis. Shout out to engineering cannabis. All right, this one is from TheVerge.com. Americans still don't trust self-driving cars. Nearly 3 in 4 Americans say autonomous vehicle technology is not ready for prime time. Let the American tell it. Self-driving cars are having a really rough time gaining our trust. This is not a total shock considering autonomous vehicles remain theoretical and elusive for most people. The limited number of self-driving cars on the road today are mostly test vehicles that aren't available to the riding public. Combine that with Americans' very, shall we say, complicated feelings towards concepts like freedom and control, and you can see where this is going. Digging on technology in the streets, control freaks in the streets. The latest poll to affirm this deep distrust comes from the Partners for Automated Vehicle Education, PAVE, a coalition of industry players and nonprofits aimed at improving the public's understanding of autonomous vehicles. A quick glance at the results reveals that they'll have their work cut out for them. Nearly 3 in 4 Americans say autonomous vehicle technology is not ready for prime time. About 48% said they would never get in a taxi or ride-sharing vehicle that was self-driving. Another 20% think autonomous vehicles would never be safe. Only 34% think the advantages of AVs will outweigh the disadvantages. Only 18% are eager to get on a wait list for the AV. These are some of the findings to emerge from PAVE's survey of 1,200 Americans who were contacted by polling firm Survey USA between the late February and early March 2020. But it could easily have been the result of any poll about self-driving cars taken over the last 5 years. A variety of auto-related groups like AAA, AAA, Kelly Blue Book, and advocates for highway and auto safety have found similar skepticism in their polls. Taken together, these results paint a pretty grim picture for the future of autonomous vehicles. After all, much of the technology success will depend on the public perception and willingness. Companies working on self-driving taxis like Waymo, Cruise, and Argo are already confronting these issues through their own pilot projects and limited commercial deployments. Of course, they have their own data and thus their own ideas on how to overcome this skepticism. And the numbers aren't all bad either. Around half of the people polled by PAVE and Survey USA said they owned vehicles with advanced driver assistance systems. Features like automatic emergency braking, lane keep assist, and blind spot detection. Familiarity and approval of these features can lead to a more positive attitude about self-driving cars. The poll finds it makes sense, but it's still a far leap between a car with enhanced cruise control and one that can drive itself without human intervention. Most people responded favorably to a vehicle that supports the task of driving, but with the driver always in full control. This is antithetical to every company that claims to be pursuing fully driverless cars. They argue that most vehicle crashes are the result of human error, and that in order to improve road safety, humans need to be removed from the equation. That's why you have companies like Cruise introducing vehicles without traditional controls like steering wheels and pedals. And companies like Neural are lobbying the government for exemptions from federal regulations requiring certain features like rear view mirrors and backup cameras. This is very true. Pave says the skepticism and distrust is rooted in ignorance and lack of experience rather than knowledge of a specific downside or problem. You hear this a lot in the manosphere. Thai City had a stream yesterday called autonomous trucking, where this was highlighted. For example, a majority of the respondents said they weren't familiar with any of the fatalities associated with automated technology, such as the deadly Uber crash in Tempe, Arizona, or any of the drivers who were killed using Tesla's autopilot system. That should be a red flag to operators. People don't need to hear about the really big failures to harbor real hostility towards the technology. The more self-driving cars hit the road, the more people are likely to trust them, Pave concludes. But that will take some time, given that many of the early predictions about the readiness of the technology have since proven to be overly optimistic. A lot of people thought the roads would be overrun with robot vehicles by 2020. But here we are, it's 2020, and the number of AVs currently testing today are a fraction of a percent.
And Mike, this is one thing I do wonder. I wonder, like the more complex roads and water on the highway, and all of these different things that can greatly mitigate the circumstances of any driver. And I would say that would be the same of an autonomous vehicle. I don't know if they're really up to that level that we would be comfortable at as of yet. From what I heard MOT saying, he said they kind of weren't. I don't know how true that is. I myself have not seen any autonomous trucks. I know they put them on the bigger, more safer highways where it's a lot easier kind of to handle it. But I think as conditions might get a little bit shaky, snow, icy roads, these kind of things, I wonder how these autonomous vehicles would handle under those conditions. I don't know if they're being tested on those conditions as much as they are on like regular, very safe highways, which don't have many of those complexities being thrown in. But I would be interested to see how those vehicles will handle those types of situations.
Well, they just won't go out. Their ability to traverse inclement weather is going to be really dependent upon what public services are available to, let's say, handle snow, right? Most of those autonomous vehicles can actually, they can park themselves and drive themselves. It's when you start putting obstacles that are beyond their control in place that should be managed by the state itself, by the government itself. That's where the problem is, right? So, because they have their own built-in artificial intelligence, they're not really relying on GPS and stuff like that, at least not initially. The issue is more about the state itself. Did they fill those potholes? Are those unleveled manhole covers and sewer covers, are they well adjusted? Those small imperfections in the road is actually what throws the car off, because the car, when it's tested on newly built roads and infrastructure, so it doesn't interpret those pieces as being part of the road. Most drivers, right, will look at a unleveled manhole cover and try to swerve around it to avoid banging it, or they will avoid a pothole that they can foresee. Most times vehicles can't actually do that. They can't go around these sort of obstacles. So even beyond snow, something as simple as what the local state government should be doing from a service perspective is really what's impacting the autonomous vehicles capabilities. And so adding snow to the road, as long as it's drivable, it doesn't matter. But if it's not drivable, then it's a state of emergency. That means that nobody's on the road.
Mike, I'm not saying if it's undrivable, because that's an extreme. I'm talking about kind of lightweight stuff where it's drivable, but yet is the AI up to it?
Yeah.
I'm not saying extreme conditions. I'm talking about just a little ice on the roads. Roads, rain where things might get a little slippery or something else like that. Where one who's skilled at driving, will be able to negotiate it rather easily, but this AI be able to do the same. And that's just an open-ended question. I'm not expecting you to give me a full answer on that. That's just something that I just want to put out there.
No, the AI wouldn't be the problem.
You're saying it's a state with respect to how the roads are
Well,
maintained.
it'll be the other drivers who make the errors.
Maybe, I don't know. All right, okay.
Oh, no, that is the case. That's been proven. That's the case. If you look at most of the Tesla accidents that happen, it's always some other person interfering, either the human behind the wheel or the opposing drivers on the road that are interfering with the ability for the car to maintain its travel.
Yeah, I can see that. I could see where that would be an issue, because people definitely make, there's a lot more error, humans make errors. So yeah, I could, there's no doubt about that. The human error factor is always going to be around.
Yeah. That's what the article is saying, that it's the ignorance of the people who don't really understand the cars itself. And so, or understand the technology itself. And that's what's causing a lot of this apprehension, right? This sort of, can the AI do this, or where's the, we don't really trust the car because we don't trust AI. But in reality, it's the humans causing all these problems. It's always been that way. I mean, not saying that the AI is flawless. I'm saying I've seen, SUVs with very light amounts of snow end up on the side of the road. All this all-wheel drive technology and all-terrain tires, and you got Jeep Wranglers upside down on the side of the road because human error. And so you take an autonomous vehicle, as long as there's a clear path in front of it, that thing's going to keep going. And which is what they find with Tesla cars, right? People sleeping behind the wheel and stuff like that. Car is going to keep going.
Yeah, but who's going to keep that path in front of the car clear? I mean,
well, remember the Tesla cars and all these advanced vehicles have the sensors on them, right?
Yeah, I know that they do. Right? Yeah.
So they're not going to run themselves into a back of a car. I mean, that's been proven, right? They slow down automatically. So
yeah, but what tells that Tesla that this car in front of them is not in an accident and they have to go around it, or the traffic is just backed up?
Oh, based on the distance. It's based on distance and speed. So if the car is stopped, that Tesla is not going to keep going forward.
I know it's going to stop, but is that computer algorithm going to say, you know what, maybe I should get in the other lane because
yes, that's what it's designed to do. Yeah, that's what it's designed to do. It's supposed to go around it, but if the other cars on the road are driven by humans and they don't let the car, they don't let the car actually pull out, right? They don't let the Tesla actually pull out on its own, and they're not adhering to the the traffic itself, traffic management itself. That's where the problems are.
Yeah, but people are not going to slow down to let another car come in front of them. That car is going to have to accelerate around whatever obstacle in front of it and get into the ongoing traffic, the traffic flow. So what now? Not only that, but
well,
the traffic, the car seeing that the ice, that the lane that is in is icy. Will it change lanes?
It should do that. That's what it should be doing. Based on the Tesla autopilot, let's go over it real quick because I know we covered this before. I wish Johnny Blaze was on the panel. He can actually he can speak to that more because he has a Tesla that has the feature.
See, all this depends a lot on well, two things: obstacles, and then the driver of the other car itself, not the Tesla or whatever car is autonomous. It's going to operate within its parameters, but the other drivers on the road, they're going to be pushing their parameters. You know what I'm
Or
saying?
maybe not, depending on if they have a brand new car or something like that. Those new cars with those collision sensors and whatnot, those lane changing features, that it may not allow the car to accelerate. And so if you're looking at this picture right here, this screenshot right here, you'll see that the Tesla system can actually monitor everything that's on the road, right? This little dashboard right here.
Yeah, I understand that. What I'm saying is, will it say that the Tesla wants to change lanes and get
That's
out
what it's
from
doing,
behind
right?
a car that is going slower than it?
Yeah, that's what it's doing right here.
Will it talk to the car that's coming in oncoming lane saying, "Hey, I'm trying to change lanes.
Yeah,
Slow down."
yeah, that's the purpose of what they call vehicle-to-vehicle communication.
Right.
That's the whole purpose of it. Vehicle-to-vehicle communication network. So all these cars are supposed to communicate with each other on the same network. So to kind of answer your question here, this is what they're looking at. You see, it's trying to make the determination whether or not it should switch lanes.
To change lane. But you see, the other guy in the left lane just speed up right past it. You see what I'm saying? So now it's got to decide: should I change lane? This guy's, gonna let me in or what?
And this is actually a pretty old video. This is from a few months ago. So I think the system has been widely updated since then. So like I was saying before, the car will, for all intents and purposes, it will stay in its lane and do what it's supposed to do, regardless of the weather. Especially if it's being fed travel advisory. Then it can make its own determination based on the data that is being fed. You can see right here, it's moving around the paths on the road. This is actually pretty good. I hope we don't get flagged for this, but if we do, it's actually pretty worth it because people have never been in a Tesla or been around, the Nissans and stuff like that with these sort of features, will be blown away by how this works.
Right.
The Cadillac I had a few months ago actually did some of this. You can always feel the steering wheel constantly vibrating and stuff like that. I was like, what the hell is this?
Looks
Yeah,
pretty good. Looks pretty good. Yeah.
this is actually really good. but this is an old this is an older version of the system. I'm just showing people in the chat so that they understand that this technology actually works fairly well. And according to the article, you know, the adoption rate is slow because people don't really understand it. Not so much about you know, whether or not the system works. All right, let me move to the last item on the docket. No, actually, we'll skip that, man, and open it up if anybody wants to get on the panel. And
earlier, you were talking about the universe that they thought was going in reverse, and some of the questions, well, some of my questions were answered, but that the biggest thing that I had in mind was at what point do they determine that? What happens when, you know, the universe that I'm in, is that the reference point, or the reference point is different?
wait, what are you referring to?
Um, the universe that they were saying it looks like it was going in reverse.
Oh, parallel universes. Yeah.
Parallel, yeah. But what reference points are they using to determine that? You know, that's the question I had in mind, because for if you're going by the normal laws of how atoms and operate, our universe is moving in a one direction. It is expanding.
Mm-hmm.
If that universe is moving in the opposite direction, is it expanding or is it contracting?
Well, that's the question that Nagon 11 was posing earlier. He was trying to determine that.
Yeah, that was the question I was asking, because if you have a parallel universe and you have the space-time continuum moving away from a reference point, and the other universe is moving in its direction as well, is the time actually going backwards, or is it simply moving away from a reference point in a different direction? That wouldn't necessarily be time moving backwards. That would be akin to you looking in the mirror and seeing your reflection. The reflection isn't necessarily the opposite of what actually is appearing within an actual space, given space. It's like an analog, like your hand being left and right. You have a left and right hand. They're not opposite of each other. It's like an analog,
Yeah.
like a mirror image per se, which is not necessarily opposite. It's just it's just called an analog. So that was the question that I was posing as well. And as far as the reference point, whether it be, you know, the time that we're in now, you know, that's something that obviously, because from our vantage point as a casual observer, the term that you're using, you know, in astronomy and astrology and all that type of stuff, we would have to use ourselves as a reference point, because we wouldn't know where the other universes is at in their particular point in time. We imagine that the time is occurring concurrently. So as we progress in time, they're progressing in time at the same rate. It's something that we would imagine is occurring, but we have no idea of determining that for sure. So, I mean, like that, the article itself was, I mean, obviously, I mean, it would take a book to really go into detail about it, but it really didn't go into detail as to what whoever wrote the article theorizes is going on.
Yeah.
Yeah, it left me with a lot of questions, and that was one of them. But Another question I have is, but if this is going in reverse of what we know, then if it's becoming a singularity, instead of it's going from the universe stage where it had expanded already to where it's coming back to the stage where it becomes a singularity, what we know about what happened to that is that it's going to become powerful. It's going to be like a star that is going into the death phase where it's sucking everything in like a black hole.
Yeah, that's what we're saying. With the amount of mass and stuff that it would have in a universe, and then bringing that to a very singular point, you're talking about it punching another hole through the fabric of whatever space time that may be a part of, and maybe blasting out on the other side, expanding a whole new universe. This could be the beginning of another big bang for another universe somewhere.
Exactly.
But here's the
who
thing.
knows? I mean, who knows, man?
Here's the thing. We can't see what the problem with that theory is, that you have no idea what the actual lifespan of a universe is. So if you had, so say for instance, the universe lifespan, like, we may already be past the halfway point. We may not be to the halfway point. So when you start looking at things from that particular perspective, there's a point where you go past the origin. So if we're already past, say for instance, we're just past the halfway point of a lifespan of the universe, then the other parallel universe will probably will either be before that point, or if we're not quite at that halfway point, the parallel universe will be past the origin of its universe.
Yeah, but the whole thing about it is we can't even begin to even determine that, because when we call the Big Bang, we look at the expansion like an explosion. Just like if you take a look at a bomb and you explode it, you can see if it's moving at a 300 feet per second, 500 feet per second. You can see how, under a timed under a timed camera, you can see just how fast the rate of this explosion is expanding. And it's where we are at a point now where they're saying that the universe should be starting to slow down and beginning to contract. This thing is still accelerating. So, and accelerating beyond the speed of light, supposedly. So, they have no answers as to what this is, what really this is all about. They have no answers. And plus, it should be, warmer from where the initial point of this explosion was, and it should be cooler as it goes further, outwards. And what we're seeing is that's not the case either. So,
part of that problem is that
there's so many questions.
The range at what we can see based on the speed of light, we can only see so many light years based on our current technology. Yeah, so we don't know if the universe is expanded beyond that, or if there's just an actual void beyond what we can actually see with our technology. And so
we can see right now we can see about 5 billion light. We can see about 5 billion light years into the past. That's what we're looking at, about 5 billion light years, which is an astronomical number.
But the problem is that what we see is not what's occurring right now. We're seeing something in the past.
No. We at least seen light that's been traveling for at least 5 billion years. We seen that, and then we can see kind of beyond, where there's still structures there that looks like that there's maybe galaxies and stuff that were there. So we really don't know. I mean, I hate to say it, man, but I like a lot of stuff that we break down in this theoretical stuff and we look at it. But at the end of the day, we don't fucking know. We're clueless. And that's my whole issue. I think we're going to need another level of physics to really look at this thing clearly. And there are others who have had some experimental ideas of what they're putting out, of what they're starting to put out here. But as of right now, we're fucking clueless. I mean, we want to sound bright and sound like geniuses, but we're clueless. And that's,
but based on what you're saying, Nagone. So you're saying
not clueless, but we don't really have the answers. Is what I'm saying. Anyway, go ahead, brother. Go ahead.
But okay, so based on what you're saying that, you know, and I'm not saying that you're saying that, but just like what some of the researchers are saying, you're looking at certain things as the universe expands. We expect, because the actual mass in the universe has more space in it, based on concepts of entropy
and infallible.
You would expect the universe to cool at a certain rate. That rate obviously wouldn't be linear. It would be like a logarithmic curve in which the universe will begin to cool as this stuff begins to space out, right? And as it cools, because it's the actual the matter is cooler, it should slow down, right? But you're saying that it's speeding up.
But we're not seeing that, and we're seeing that that not only is it's not slowing down, it's accelerating, and it's accelerating.
So if it's speeding
past
up,
we don't have answers.
But here's the thing, though: if it's speeding up, right, then you could surmise that there is more time ahead of us in the universal lifespan than what has already elapsed. So, with that being said, if you have a universe,
we don't know.
Okay, but we'll just play this out. If that's the case, and you have a universe in which, this is the reason why I say that time, we can't look at it as time going backwards as opposed to time moving away from a common reference point. Because if time is going backwards in the opposite universe, right, and we still have more time ahead of us in our current universe, in that parallel universe where time is going backwards, right, they have less time ahead of them, right, than what has already elapsed. So they should already be past the point where the universe in their universe, the actual origin occurred. So they should be beyond their Big Bang, going reverse. So then they're past the Big Bang.
How do you come to that? How do you come to that?
Because if time is moving backwards, like it's just simple mathematics, right? Because if you have time moving backwards, right, and we have more time ahead of us, they should have less time ahead of them and more time behind them, but in the opposite direction.
That would presuppose that universe would be the same size as ours. How do we know if it's the same size? Could be bigger, small? We don't know.
Well, it's a parallel universe.
We're saying parallel. But is it really parallel? Is it exactly the same size? What do we know about that? We don't. I'm just saying.
These can't be parallel if it's not the same size as ours.
Well, you have parallel lines that run parallel, but one may be longer than the other, and either shut off parallel for a minute, parallel for a certain period, and then that line may curve and move into another direction that moves away from what we have. That's. Parallels is just a temporary condition, if you will.
Well, then
we don't know, man. Also... I'm just saying we don't know. And based on this article I'm hearing, I would have to look at it more, and I would like to listen to some of the scientists who were sitting back here who were really dealing with this at this level, because I understand this pretty well, and some of this shit is just, to me, is like too many questions, bro. Too many questions for me to really sit down and too many variables. And I hear where you're coming from, but I'm just saying, I'm not really in any position to really judge this too tough, because this is a new one on me, man. And I'm like, what is this? I would definitely like to look at this more. I hear where you're coming from, brother. I mean, you may be right. I'm not questioning whether you're right or wrong. I'm saying these are some of the variables that we're looking at. And I know in science, you have to eliminate some of the variables or being able to solve for some of them to really, get a good idea as to what is really going on. And I don't know if we're even anywhere remotely, near this point, because there's phenomena going on in the universe right now that we can't explain, such as the even temperature of the universe around. And it's supposed to be expanding, and we see that the galaxies right now are expanding at a greater speed. So we are coming, you know, a lot closer now to the Andromeda than where we are in the Milky Way, and we're moving at very high rate of speed to do this, and we're not quite really understanding how this is happening. So a lot of questions here, bro. That's
the other question I have is how they know that they are speeding up and we're slowing down instead of we're speeding up and they're slowing down.
This shit is conundrum. This shit is a conundrum. I'm just like,
I mean, I had so many questions. It's like, man, something's wrong here. You know, according to what I know, according to what I can remember from science, you know, or the little electric universe that I know about. How they know? It's like me and a guy going down the road at the same time, speed, and then I started falling back. Did he speed up? I'm looking at him and see. I'm thinking that he's speeding up before I look at myself and realize that I just come off the accelerator. You know what I'm saying? So this is really, it's throwing my mind into a what?
Well, I mean, like, so if like, okay, let me bring it to you. Like, somebody asked also in the chat, are there perpendicular universes? And they LOL. Not that was actually a question I asked earlier too. But so okay, so say for instance, you had like, okay, so if I'm looking at a stellar object that's off into the distance, say for instance, this object is 1 million light years away, right? And I'm looking at that object, and maybe this object is in motion, it's spinning on its axis, right? And I can actually see the object spinning. If I had the technology, I can see it spinning on its axis. If I were to move towards that object at any given speed, because I'm increasing the rate at which the photons emanating from that object, reflecting off that object, actually reach me as the casual observer, it would appear as though if that object is speeding up because I'm moving towards it. Now, if that object begins to move towards me as well, then it would appear that the object is moving in. In fact, it almost like looking at a VCR. You know, you're looking at a TV and a VCR, and you fast forward the actual whatever you're watching because you're moving forward, and now the photons that were emanating from that object, that rate at which you actually receive those photons is increased. So if you have an object, right, that you're moving away from, say for instance, you were able to have light move away from you as the casual observer, and the object was moving in the opposite direction. It's almost like the quote unquote parallel universe. Instead of speeding up, you're slowing stuff down to the point where now it's going from beyond slowing down to actually moving in reverse, because it's moving in the opposite direction from that actual point of origin. So it's only moving in reverse from our particular perspective, but from that perspective and that opposite or parallel universe, their time is moving as it should. In actuality, from their perspective, we're the ones that's moving in reverse, simply because we're both moving in opposite directions.
Is that it? Anybody?
That's it.
Anybody?
I was waiting for somebody else to say something.
I don't know, man. Like I said, I have like I said, I'm looking at this. I know for a fact, if you're approaching something at the speed of light, and it's actually coming towards you when you're traveling at the speed, you're actually traveling at the speed of light, it would look slower. All right, as you pass by and you see it moving at speed light, it would actually stretch out, expand, and then it would kind of shrink. It would stretch out as you see it. As the light's coming towards you, it would look slower if you're traveling at the same speed. Then as it passed by, it would lengthen, and then it would shrink as it goes off, almost like a Doppler effect.
Yeah.
It's called redshift. It's called redshift.
That you would have, yeah, but that's what I'm just explaining that.
Redshift is going to make it appear like it's speeding up after it passes you.
Yeah, that's
right.
that's what I'm saying. It would look at the same. It would look the same. It would look slow as you approach it, but as it passed by, it would shift. It would stretch out, and then boom, and it would get, and then it would shrink as it moves. As it moves away, it would be redshifts. It was almost like it would be like a Doppler effect, like you have with a train. The train comes up, kind of deal. That's kind of how we would kind of see that from a perspective of light. But how would we be able to see that, and would we be able to judge which is going backwards and forwards from our position? It should, as we say, from a relative position, it might look different from one angle to the other, but it would potentially be moving at the same speed. So, hard to say, man. I'm just looking at the stuff. It's going through, and I'm more or less basing my ideas more on the Einsteinian type of physics. That's about the highest level that I understand. There's other stuff that's out there that I'm not familiar with, but that's how I would be looking at it. So trying to judge it from that perspective, it would be kind of tough to see. I don't know. It would be tough to see. It would seem to me that if it's going in the opposite direction and it is moving oppositely, counter, it would be shrinking. We would see some shrinkage with this, but maybe not. I don't know. Is what you say may be right, maybe wrong. I don't know. I don't know. It's definitely these are some good thought experiments, but I don't exactly know where we would be with this. Mike, you have anything else? I know Gabe said he had a question in the chat that he.
Hey, Nagon, are we capable of seeing beyond our universe or extrapolating beyond our universe? I haven't seen any information about that. How did they?
These are strictly how we say theoretical models and theoretical designs.
Well, I think they're basing it on neutrino action, which because they have telescopes that are just neutrino telescopes, and that they basically I forgot how the technology, I read about this, but the technology basically absorbs neutrinos, and they use like a computer to kind of generate an image based on the neutrinos that were absorbed by this. It's not a telescope in a conventional sense, but it is a telescope in the fact that it collects energy. Telescope. Yeah, there you go. Right, there you go. Right, but they use some type of computer technology to generate the imagery that they see, and what they're seeing, from a mathematical standpoint, doesn't resonate with our universe. It has to be something else. And I guess they're theorizing that it's basically some type of energy from a parallel universe of some sort. But the question is that how did energy from another universe that's moving in a different direction from the vantage point than we are, how did it reach us? Unless there's some type of portal. Like, Mike was saying earlier about a black hole perhaps being some type of gateway to another universe, but I'm just trying to figure out how that light energy got here, or neutrino energy got here.
Well, the thing is about the black hole theory, and I want to go to vision next. The black hole theory is that on the opposite side of the black hole is a white hole, and that the white hole reconstructs that matter that was mangled or whatever, destroyed, and it rebuilds it back up. So you talk about a parallel universe, it's got to be coming from there.
Why couldn't it be I'm just asking this question, Mike. It'll be enough. Why couldn't it be like a mirror, like a reflection of mirror that Super Tristan just mentioned, your left hand, right hand thing? You know what I'm saying? It's just we are moving towards this mirror in the universe, in our universe, or surrounding our universe, and pow, we see these whatever neutrinos that they're collecting bouncing back at us, and they're coming back at us. Maybe we imagine the speed faster than us.
Well, that's what I'm saying, and this is the reason why. Remember, I was saying this means that there has to be faster than light speed travel. because if you have something moving away from the vantage point, opposite from what we are, in order to reach us, it would have to move faster than the speed of light to get from that universe moving in an opposite direction.
Exactly. Anyway, vision.
So that means that faster than speed of light travel is possible. I mean, at least if this theory holds true, it would have to assert that. It's like it was like an if and, you know, kind of problem. If and statement, if then statement.
Let's go to Vision. He has his hand raised. Go ahead, Vision.
Oh yeah, fascinating subject. You guys are talking about Pearl Universe. Here
Yeah,
I am
put the
looking
volume
at
on your mic, bro.
I'm sorry. Raise the volume.
Yes,
Yeah, your mic's a little low.
Hey, put some respect on your mic.
Okay, how about now?
Hold on a second. I want to say this very quickly. Faster than light travel, anything that holds mass can't do it by the laws of physics. There's a new physics out there. I'd be interested to see it. But by the laws of physics, right now, Einsteinian physics, it cannot be done. Okay. And we have not simulated it in a laboratory either.
Well, I'll debate you on that later, Nagon. I think it's possible. Not to say but I'll debate you later.
There's no debate. like I said, especially like talk about these females. There is no debate.
Let's go to Vision.
Go ahead, Vision.
Can you guys hear me better now?
Yeah, we can hear you definitely.
I was going to say, fascinating. You guys are talking about parallel universes, and here I am looking at Stephen Hawking's A Brief History of Time. The book is just collected dust. I've never even opened a page on it, but he was dealing with one universe at that time. So it's fascinating how that subject has changed. So, but I don't know much about that. So what I wanted to talk about was when Mike earlier was talking about if we as a society, and I'm just paraphrasing, are going to accept like automated cars on the road. And there's a story I would like to share. I remember this communications professor was explaining, and he said there was a time where you had people that dealt with horses and carriages only. And then I believe it was a Ford T model. Don't correct me, forgive me if I'm wrong, but a car came, the first car by Ford came out. And then you had a generation that saw both the horse and carriage and the car. And then they sort of dealt with that. And then what happened was that you had a following generation that came after that, where the only thing they remembered was the car. The horse and carriage was still there, but it was a memory. And there's been times in history where that happened, you know, like radio to television. But we like us here, we're considered the Google generation. And what they mean by that is we come from a time when we didn't use Google for anything. So like we used to remember phone numbers, things like that, right? And so all of a sudden Google came out, we were here, and now we've got children that are coming after us. And basically when we die out, right, and our children and grandchildren take over, they're only going to remember a time where they Googled everything. They're not going to remember a time where they had to memorize things. And so like the neural pathways in your brain that are not used for such things are basically changed for, you know, for the new shift. So that's called a generational shift. So I think the next generation, like this next generation, has grown up with technology, and it's an alarming rate. What I mean by that is, like, I see kids coming out of their mother's stomachs already knowing how to use tablets and smartphones and turning things on and off. And so like they have an advantage there. And so I think once we die out, all this like, you know, you guys talk about it, this fourth wave industrialization, 5G and everything is going to be
a Vision.
Yeah.
Vision. You seen babies coming out the box to get live with a tablet? Oh, that's Butterland. I like to see that shit. I ain't seen that yet.
Well, I was exaggerating, but like at 3 or 4 years old, this kids knew how to use it. Yeah, I was exaggerating, but you know what I mean by that.
Yeah, I got you.
Yeah. So I just want to add that. So yeah, when we die out, this next generation, they're going to take it somewhere else. They're going to accept all the changes that are coming in technology. That's all I want to say.
Yeah, that's a fact.
But Vision, what's your thoughts on parallel universe?
I have never studied it in my life, man. I haven't even studied our own universe, so I can't say
none of your Hotep books have any of that knowledge in it?
Okay. Wait. The Hotep books? No. can't, talk about
You guys got Vision too excited, man. His phone stopped working.
Yeah, he got too excited, man.
Went into a space-time continuum.
He went into the state of the Borg. The Borg
Hey,
galaxy.
he's trying to tap into his 13th chakra.
Yeah. Anyway, they said on the other side of every black hole is a star, right? So I don't know, and that was their
Well, a black hole was supposed to be a
universes.
Well, you know, they said on
a collapsed star.
What they said is on the other side of every black woman is a Hotep Negro.
Oh, no.
Yeah, man, and through that you can get the singularity. The singularity is up in that mama. You can get the singularity right there.
Singularity game division.
Yeah, I had no facts on it. I have no facts.
Well, hold up, Mike. What type of black hole are you talking about now?
I'm hoping when that's I'm not even gonna go there, fucking Tristan.
Okay, we could get into triple what is it called, triple layer, is it triple darkness and all that stuff, but again, I never did the lessons on that, so I can't talk either. But yeah, we could go forever, but nah, I can't. I didn't follow all the way, so I can't speak on what I don't know.
Well, parallel Hotepism, right, says that a woman can reproduce a child without the insemination of a man.
Yeah, it's black girl magic.
Oh my God.
Oh, no.
Black girls rock and shit. Black girls rock. But anyway, yeah, man. I would like to see that.
Hold up. But just real quick, I want some smoke when the gone. Talking reckless. Now hold up. Now. Is light not moving at the speed of light? In the
Is light not moving at is light? Oh, you want to smoke with me? This ain't the BGS hangout, is it?
No. Is light not moving at the speed of light?
Is light not moving at the speed of light? Light is moving at the speed of light. It is.
Okay, so we know that light interacts with gravity, called gravitational lensing. When we look at a black hole, if we look at a black hole, there's a phenomenon. A phenomenon occurs around black holes called gravitational lensing. So we know that light and gravity interacts, right?
What does gravity do to light? What does gravity do to light?
It causes an interaction of some sort.
It
gravitational lensing.
Gravity or the gravitational force can potentially bend light. It bends light. Bends it.
Okay, but check this out, right? So if you have an object, if we have an object with mass and we take a celestial body, we can take that object, go around the celestial body and do what's called slingshotting to increase the speed of the object.
That's not going to increase the speed of something moving at the speed of light.
How do we know that?
Because the problem that you have with this is this. As you travel with the speed of light, with greater speed, you increase your mass. You become more massive as you increase. Now, mass is not a question of size. Mass is a question of density. All right. And that you become denser, you become heavier. You become actually heavier as you travel at a greater speed.
Okay.
That's what happens. So as you travel with the speed of light, you actually hit basically a constant where you cannot actually, once you hit that speed, 186,000 miles per second squared. All right. At that speed, as you try to move faster, okay, as you get heavier, you cannot increase your speed.
Yeah, I'm aware of that.
Because your mass slows you down. So you cannot add on. As you try to add on, it still gets heavier. So it keeps you from moving faster. You feel me? That's what we're dealing with respect to, just like you have a gravitational constant, you have a speed constant. And that's
speed constant
that we haven't been able to break.
Well, I mean, we haven't been able to break it yet. But I'm thinking
there's no science out here right now that can help you to do it. You can't add on, you can't push it faster. You can't do that because as the faster you go, the more massive you become. That's the problem you have. That's what keeps it at that constant speed. Guys far smarter than us been fucking with this for well over 100 years. All right, and since the days of Einstein. So it is what it is. Seemed like the ancient Egyptians understood this as well. So or maybe even those who came before them. So this is where we're at with this, bro. I don't know what more. I don't know what more to tell you.
Hey, are you familiar with sound waves?
Yeah.
Okay.
What's up?
What's the, let's see, blue, the color blue. You can remember what wavelength that's at?
Do I remember what wavelength the color blue was at? Blue, red, shift.
Yeah, blue is at the faster end.
I don't remember the hertz. I don't remember the hertz of
blue is at the faster end.
Of them now.
Exactly.
Okay, what's up, baby? What's the question?
Yeah, do you consider a sound wave to be matter or not?
Is a sound wave matter? No, a sound wave is really more it's energy. It's energy, and what it does is it actually disrupts the medium that it's in. It travels through a medium. It has to travel through a medium in order to make sound. That's why in space, in outer space, where there is no atmosphere or medium to carry a sound, you have no sound at all. You could.
Well,
I could be standing right next
but here's
to you.
the issue.
How do you know that?
You wouldn't hear me.
No, yeah, that's the debate, Nagone, because
but sound, but
there is
sound,
no empty space.
But sound and light are two totally separate things.
No, it's not. You can't have light unless you got sound.
Are you kidding me?
Light is the result of a frequency of sound.
Go back to your science books and read that again.
Light is the result.
I'm not even going to get into it. You cannot have sound. Listen, there is no sound in space.
Okay.
There's plenty of light. That's the
but here's the thing, Nagone.
All right. Anyway, go ahead.
But for some physicists theorize that in space there is a medium, that there is no such thing as empty space. All space is occupied either by dark matter.
Yeah. You may have dark matter and all that kind of stuff, but we're talking about a medium. I didn't say
but dark matter would be a medium.
Oh, hold on a second. Don't interrupt me, man. I'm just gonna hit you with this. The medium that we're talking about, like we have here, that propagates sound, it's either through sound waves that travel on air, and they travel a certain distance. Where underwater, which is more dense, a dense medium, sound can travel a lot farther because it's denser. It can carry a lot farther. That's how whales can damn near talk to each other. They may halfway across an ocean with certain kind of sounds that they make, where they wouldn't really be able to do that in this lighter medium here of air. But that's what carries sound. The density and thickness of the atmosphere. There's no atmosphere in space.
But,
there's no atmosphere.
And water, no low frequency sound will travel to water. High frequency sound will boil water.
Low frequency sound travels. Just understand how whales.
I know that, but I'm telling you, high frequency.
Anyway, I'm done with this, guys.
Sound at a high frequency will boil the water. Am I correct?
You're correct.
Okay, so there goes your theory about there's no sound in space.
There is sound in space. We listen all the time for sound in space.
No. You're catching the sound of waves. You're catching the sound of particle waves that come through, microwaves, these types of things. That's what we're catching.
All sound.
That's sound.
That's what we're catching. And these are energy. And these are energy waves. Go look in your books.
Time out.
Go look in your books. Go look in science books, and see At what frequencies or what sounds that we can hear in space? What can we? So if you're sitting in outer space, you're telling me you're going to be hearing sounds.
Well, that's different. No, go. Okay, there's an excellent website called physics.org.
Yeah.
That
Well, okay.
Wait. Let me finish. There's that explains a lot of this. There is not the medium that we're used to hearing in sound.
Yes, exactly.
But I'm trying. Okay.
There are microwaves that you can hear. Okay, but then you need sensitive sound equipment to pick that up. You're not going to hear that yourself.
Right, because when I agree with that. I'm not.
And that's what I'm saying. Okay. So
okay.
go ahead.
No, I just want to say to talk about how we travel faster. Are you guys familiar with I hate to say this, but it's like the Alcamari drive, a physicist from Mexico that theorized the same thing that Einstein did, that we can fold the space in front and back of us and push ourselves. So we could theoretically, and even Hawkins said that we can move fast. If this could be true, we can move faster than the speed of light. So so we can actually go around what they say about, basically, as Nagon pointed out, the technical thing of trying to travel faster than light, because you increase your density. The thing is, you actually fold the space
heavier
in front of you and fold the space in back of you.
Yeah. We talk about that's warping space. That's moving space, so that can potentially do that, and that's theoretical. We can definitely see that you can warp space, because that's basically how Einstein's theory of space time was kind of proven, was during a solar eclipse, and they were able to see, as the sun was blocked out, they could see stars that you shouldn't be able to see, that were right behind the sun. You could see them that were right behind the moon or so. You shouldn't be able to see them, but then during the eclipse, you were actually able to see them, because the light had been bent around the mass of the sun. You could be able to see to see it that way. So, like I said, extraordinary gravity, as we say, can bend light. That's why in a black hole,
no, that's not true anymore. This latest exercise with the black hole.
We just saw
another picture.
They just saw a picture of where you had a circle. Literally, they imaged just the image of a black hole, and it's blackness in the middle of it. Ain't nothing coming out in the middle of the mother.
No, they had another one.
No.
I'm telling you, you got to look at the latest one. Ago, there was another.
It's not even that new, because so this is what I was talking about, right? So what I spoke of when I said gravitational lensing, that's exactly the phenomenon that's occurring. It's causing the light to actually contort around, because the gravity has an interaction with light, right? But how can gravity interact with light unless photons have mass, right? So, but photons have mass. Well, hold on for a second.
Light gets bent out of extraordinary
gravity.
Okay,
but how can gravity interact with something that has no mass? That means photons must have mass. Yet photons travel at the speed of light.
Go ahead.
But photons somehow that have mass travel at the speed of light. So what?
You remember any of your physics at all? Did you take any of this?
Absolutely. But here's the thing, right? So you have a black hole, singularity. You have X-rays that emanate from black holes. So you have X-rays escaping black holes. You have X-rays escaping that gravitational pull.
X-rays do not escape out of. X-rays do not.
They call jet streams.
X-rays do not escape around black holes. You had X-rays that were around black holes. That's
no. You're talking about an accretion disk. You're talking about an accretion disk. That's something totally different.
That's how I say X-rays do not come out of black holes.
You're talking about an accretion disk. That's something else.
That's something else, right? Go look it up.
I know. No, I've already looked it up. I've already done a research.
No, you haven't. No,
yes, I have. Yes, that's what I'm talking about. It. So you have an accretion disk. You have an accretion disk that
nothing comes out of a black hole.
You're not listening to what I'm saying.
The only reason
you're not listening to what I'm saying. You're not listening to what I'm saying.
We just imaged.
You're not listening to what I'm saying.
You just saw it. You saw light bending all around.
You're not listening to what I'm saying. You have stuff heating up. You have stuff heating up around. It's called an accretion disk. Yeah, we know about that, right? But you have jet streams of X-rays that emanate from black holes.
What you see is it's excreted coming out of a black hole as it shoots up, as the energy spins so hard. You see stuff that starts to shoot up, not out of actually out of the black hole, around from where the center of it is. It shoots up. You can see this in some of these you can see this in some of these. What do you call I'm trying to remember the shape of these types of what do they call quasars? And not so much quasars, but the ones that kind of spin around, where you can see stuff being extruded out of it, where you can see like material being thrown out, being literally
pulsar,
being literally kicked out of it.
Pulsar.
But as far as it's actually kicking out some of this energy that's coming out of it because of the extraordinary amount of spinning that that you get at the event horizon. But as far as it light coming out of it, no, that's why it's a black hole. You can't see anything over there because it's black. There's nothing coming out of it. The density is so deep. The density, its mass is so it's so much mass there around that hole. Nothing escapes it. Nothing can escape the black hole. Nothing can escape it. Nothing escapes the motherfucker. Nothing.
Okay.
Nothing. So that's why you can't see it.
But okay. Go on. There's a thing called Veritas where it basically where they have a neutrinos where they were showing that energy is coming out of the black hole, and that's what I'm trying. Wait, let me finish.
You see excreted coming out. Don't say let you finish. I'm telling you.
I'm just trying to make a. I'm just trying.
Is a black hole because nothing escapes it, bro.
But then how is it? Okay.
That's why you can't see it. You have to look at it for what's around it. That's how they look. That's how they look at it. Don't look this shit up.
We're not.
You got 1,001 freaking you got 1,001 videos on YouTube talking about that.
We're not talking about the accretion disk. We're not talking about the accretion disk.
You cannot image a black hole.
But listen what I'm saying, Nagon.
Because you can't see
light. There's light outside of the visible spectrum.
You have what's called the event. You have no. You have the event horizon.
I know what the event horizon is.
You have the event horizon. As far as the black hole itself, it's a black hole because, as Einstein said, and that's why he didn't even know that they existed, but through his science, he was able to predict this because he said there will come a point where you will have an object that will be so infinitely massive, nothing will be able to escape its massive gravitational pull that it will have, not even light. So you actually will not be able to really see the hole itself. How you'd be able to freaking take a look at this hole? So you'd have to image the environment around it. And that's the only way you would be able to kind of see it. That's why they say at the center of every galaxy, there's a black hole around it. All right, there's a black hole. Some could be small, some could be big. That's the whole thing. But it's a black hole. You can't really see it. And these guys basically came up and had an image of what this thing looked like. Just recently, we actually had it here on the Black Brain Trust, and we saw exactly what that image looked like. And it was a circular amount of, looked like it was fire around a black fucking hole. All right. That's the whole thing, that this thing is so massive, nothing can escape it. So you're talking about, we see light coming out of it. What the fuck are you talking about? It's a black hole. That's why they call it that. What the fuck, man? Damn.
Okay, so basically what I'm saying is that there's light outside of the visible spectrum. So there's light that you cannot see, but technically is light. You have ultraviolet radiation, you have X-ray radiation, you have gamma ray radiation. Right? That's light. But somehow, and I'm not talking about an accretion disk.
All right.
Somehow X-rays.
Listen, like I said, I'm done with this, man. If you want to go take a look at it, go take a look. I'm done. I'm not even debating this anymore. This shit is over. All right, it's over. Go take a look.
That's
Go
the good thing
research it.
about physics. That's the good thing about it's changing.
It's here on YouTube, and they go into nice detail on it.
Let Super Triz finish his comment. Then we need
Go ahead, let him get it. He's got it, man. Go ahead. You got it. I'm done.
So what I'm saying is that, right? So if we have an actual black hole that distorts space-time, if you actually distort space-time and you accept an association of space and time together, that distortion, based on what we actually theorize, that time actually changes as you approach the event horizon. Time begins to move slower, or at least you, as the observer from within the black hole, because that space-time continuum has been stretched out. You appear time to be going at a different rate than people outside of that black hole, right? So you've essentially slowed down time, yet light emanating from that area still moves at the same rate. So in actuality, there's a point where light is actually exceeding the speed of light if it moves away from a black hole, where space-time has been distorted around it.
What are you talking about, bro? I mean, it doesn't make sense. It doesn't make sense. It's not making sense. Go ahead, man. Go.
We gotta let Vision.
Okay. I'm sorry. That's it. We talk.
So you guys can continue this conversation. Nagon, what you're talking about is, I remember something called a supermassive black hole. So I do remember that. That is supposed to be the center of every galaxy. But Mike, remember earlier you said what anything from the Hotepis?
Okay.
Here I'll just read this one quickly, and then we can get back to this debate. It goes here: just as the three great pyramids of Giza in Egypt model the belt stars of the southern constellation of Orion, so too do the principal monuments of Angkor model the Sirius coils of the northern constellation of Draco. So ancient people knew how to build structures that would align with heavenly, stars, and that was quite fascinating. So there is a science to that. So I think that was like the more factual aspects of the Hotepi community. The other stuff just gets out of this world. So yeah, continue your black hole debate, guys.
Well, that's not the first. You look at most ancient people, the Dongo people of Africa. They can tell you the stars from their naked eyes because they've been studying this for the longest time. And you have the people in the Mayas. They did the same thing. So astronomy is something that we all look up to and say with great awe and all that. I didn't know this was going to be a physics talk. I would have came prepared. I would have brought my books.
You would have, man.
It be like that, man.
Yeah. We get a little live, man. We get a little spirited here.
So you want to talk about the quantum teleportation? I thought that was a realistic and thing that's real world. We could use that for networking. That's a real world application, quantum teleportation.
We talked about that some months ago, probably last year. We talked about teleportation.
Oh, see, remember, I'm a new person. I'm sorry.
Yeah, we're gonna do a chat on quantum teleportation and transhumanism. We got to touch up on that because what do you call it? Zero did a great job on his channel with talking about transhumanism. And a lot of Negroes are not thinking about going beyond their human capabilities, man. And fifth industrialization, sixth industrialization.
Well, it's not. It's now with gene therapy and the ability to manipulate your genes, transhuman and stem cell. It's now. People are doing it now.
No, I'm just saying most Black people don't think beyond, beyond where we are right now. They don't think about that. They don't think about that.
Because there's a clinic in Colombia where they're talking about moving your extending back your telomeres back to and I don't know if y'all covered that in your transhumanist thing about the telomeres or uh, about how they affect aging, and there's a few other genes that also do that. So it's happening now, basically.
Yeah. Yeah, I think we come to the end of the live stream. Thank you all for joining us. Please hit the like button if not already done so. Share the video if possible, and hit that notification bell so you get all the updates from the Black Brain Trust, including those posted on the community tab. Docket in description, leave the video for you to reference. And thank you to everyone who participated in this discussion, especially Triz for showing up first.
Yeah, Triz, good rapping with you, man. Good rapping.
Oh yeah,
good rapping to you guys, man.
Yeah.
You know, we get live over here. You know how it gets anyway. But you know, I got mad love for it. It is what it is. All right.
All right. Shalom, everyone.
Peace.
Peace.